Alright, back at it again. Day 2 of our Mega Cram study session. We are on section 2 of the CompTIA Network Plus in 10-009 exam. We are working on examples, characteristics, and routing technology. Not topology. Technology. I suspect that this one is going to go a lot smoother than last time. Last time we had 8 sections to go through, which, just so you know, section 1 is a third of the entire test material. Insane, right? Absolutely insane. Let's knock this down just a little bit. And everything should be working. I haven't really messed with any settings. Let's give a little test real quick.
5. Real world example.
Perfect. Let's go ahead. Let's start diving into it. And welcome back. My name is Tyler Lamont, also known as ParaDiddlePete. I am your musician friend. Well, I can't say that. That might get copyright. I'm your friend who is also a musician, who is a drummer. I am a tech enthusiast. I am a network god. I do all of the things, and it is early morning. My hair is a mess. I'm wearing a Spider-Man shirt. I have my tea. Let's do it. Which routing protocol uses the destination address? I don't know why I just said distinct. Destination address 0.0.0.0.0. It's not quality of service. It's not static. Static is what you do when you just put it on something. And just so you know, as we go through these things, I'm trying to give you guys test-taking skills and showing you my process of how I do my problem solving to figure things out. Why? Come on, go away. I don't want to see these red lines. Ugh, okay, there's nothing I can do about that. Anyway. Wow, that was already over. Let's loop that. So we have the jams. So quality of service, no. Administrative. Distance, no. I'm going to say default. Yeah. Okay, so the reason or how I got to that is that I know what static is. Static is when you just actually put something in manually. Quality of service is literally as it sounds. It is the quality of a service that you are giving. Administrative distance, that is another vocabulary term that I cannot remember what it is, but I know it has nothing to do with an IP address that's all zeros. So default must be the answer. All right, let's see here. Are you going to do the thing? Sometimes I have to do it like 2 or 3 times for it to do it. QA.
A network uses a dynamic routing protocol that requires the administrator to provide weighted elements such as reliability, bandwidth, and load. Which routing protocol is being used by the network?
So we have a routing protocol. It is providing weight elements for reliability, bandwidth, and load. Let's see. I need to get a better thing for my mic. It's kind of like falling. Board gateway, a broad gateway protocol, routing information protocol. I think it's RIP. Enhanced interior gateway routing protocol. Open shortest path first. No, I'm pretty sure it's RIP. Oh man, okay, I remember doing this. I had ChatbotGPT. This is how I did to study this. I had ChatbotGPT go through all of these different acronyms, and I rode my bike for like 30 minutes or an hour, and I just had it constantly read me its output over and over and over again. I want to read these again. We're going to come through these again. Okay, what was wrong anyway?
A technician is reviewing the routing gateway protocols for the organization under the autonomous system as control as a single owner. In reviewing the available protocols, which one identifies routes within an as?
Well, it's definitely not TTL. That is time to live. As controller as a single owner. Man, so I'm having a hard time remembering. It's been a long time. These three all mean different protocols of how traffic is worked. So like for instance, there's one that only worries about like government and borders, making sure that the information can physically travel. So for instance, why you have a VPN to access certain things because you can't access it in America. I know there's tons of news articles that I use my VPN because America blocks a whole bunch of news. Same thing with there's one that's really outdated that it counts the hops and it uses that knowledge to try to go the shortest distance, but it actually turns out to be like the longest distance. And because it's counting all the hops. A hop is where the information has to go from one spot to a router and it hops to another router, hops to another one. So think of like a truck that's driving and it wants to go from here to, I don't know, New York, and it's trying to get there without taking with taking the fewest amount of turns. Yeah, there's quite a few. There's another one that is a Cisco. It used to be proprietary. It's a Cisco thing where it uses it factors in a bunch of things like load balance, like distance, traffic. It factors in a bunch of things. Actually, I think it's this one. I think this is the one that was Cisco. What is this one asking about? Okay, now that I've kind of dug deep into my brain, there's like two others that I can't remember. A technician is reviewing a routing gateway protocol for the organization under the autonomous system. I think that's, I don't know, we're gonna do this. Hey, one of them's right. Okay. I should have just gone with it, but I was afraid of getting it right by accident.
A network contractor is reviewing the algorithms used for path selection. The algorithms categorize according to the topology and metrics used to build and update a routing information base. It also prioritizes optimal or least cost paths. What algorithm uses the number of hops to determine the destination as a metric?
Routing information protocol, static routes, hybrid routing protocol, distance vector. I'm gonna say distance vector, although I think it's RIP. Okay. This is a good review sesh.
A network technician is looking at various administrative distances to see which route would take the longest. Which of the following would have the highest administrative distance?
An administrative distance is the amount that data has to travel between two offices, I think. I feel like I just made that up. Okay. Which of the following would have the highest administrative distance? Man, I don't know. I gotta review this stuff. I feel like I went really hard on it, and then since I didn't come back.
What is the primary difference between a subinterface and a switched virtual interface SVI?
Oh, a sub-interface is real. A switched virtual interface is not real. It's virtual.
A subinterface requires a physical interface, while an SVI does not. Subinterfaces are used for routing between VLANs, while SVIs are not. An SVI can only be used on routers, while subinterfaces are for switches. SVIs are used for encrypting VLAN traffic, while subinterfaces are not.
Yeah, it's in the name, a switch virtual interface. Duh.
Which statement is true regarding the configuration of routers in a FHRP setup? Each router must have the same MAC and IP addresses. Each router must have a unique IP address, and they do not need to share any common addresses. Each router must have a unique MAC and IP address, but they share a common virtual IP address. Each router must have a different MAC address, but can share a common IP address.
No, they have to share a common virtual IP address. What a virtual IP address is, if I remember correctly, and I'm gonna do an unsure so that we can go through these answers again. A virtual IP address is like you have two routers and they're set up in a way so that way if one goes down, the other one takes over. So they share one virtual IP address in the event that if one goes down, it can adopt that virtual IP address. Ooh, let's go. Yes, I did just do the little frat snap. Okay, here we go. There's a guy in college who used to do that all the time, and I learned how to do it so that way I could make fun of him.
A host uses Internet Protocol version 6 IPv6. The host sends a packet to another host, and a router informs the host of a better route to take. Which protocol facilitates this function?
Okay, a host is using IP version 6. The host sends a packet to another host, and the router informs the host of a better route to take. Which protocol facilitates this information? It is not DHCP. That has to do with giving out private IP addresses, which we went in depth hardcore yesterday. Dual stack has to do with like IPv4 talking to IPv6 and vice versa. Where basically like you have both. Neighbor discovery protocol, and then routing advertisement. I'm gonna say neighbor discovery protocol. Yeah. I don't know why I know that's the answer. I just know that's the answer. That is why I made it unsure. Let's learn here. We're definitely gonna use a little bit of ChatGPT. Next question. Thanks if you the first time coming by. I'm starting to do a lot more networking stuff on my channel, so if you like it, go ahead, like, subscribe. I do play some video games from time to time and things like that, so if you like that stuff, you should subscribe as well. The network stuff that I'm doing and the tech stuff I'm doing is new to the channel, so you won't really find a whole bunch of that stuff on my YouTube channel. Let's see what it says. Let's see what this has to say.
The Enhanced Interior Gateway Routing Protocol, EIGRP, is a distance vector-based routing protocol and uses a metric composed of several administrator-weighted elements. The Open Shortest Path First OSPF protocol is suited
Open Shortest Path First. Okay.
to large organizations with multiple redundant paths between networks. It has high convergence performance and was designed for the outset to support classless addressing. Routing Information Protocol RIP is a distance vector-based routing protocol. It uses a hop count metric to determine the distance to the destination network. The Border Gateway Protocol BGP is designed to be used between routing domains and is used as the routing protocol on the internet, primarily between internet service providers, ISPs.
Okay. Okay, that kind of shapes some things up a little bit.
Let's break it down. 1. Restate the question.
Yep.
What dynamic routing protocol allows administrators to assign weights based on multiple metrics like reliability, bandwidth, and load? 2. Simplified answer. Enhanced Interior Gateway Routing Protocol EIGRP is the correct answer. 3. Analogy. Think of routing like choosing a path on a GPS. Some GPS apps only use distance like RIP. Others use only fastest routes like OSPF. But EIGRP is like an advanced GPS that considers traffic, speed limits, road quality, and tolls to choose the most optimal path. 4. In-depth explanation. Let's look at each option and why EIGRP is the right answer. RIP Routing Information Protocol. Old and simple. Only metric, hop count. Max hops 15. Doesn't care about bandwidth, load, etc. OSPF Open Shortest Path First. Link State Protocol. Uses cost based on bandwidth, only lower bandwidth equal to higher cost. Doesn't consider load, reliability, or delay. EIGRP Enhanced Interior Gateway Routing Protocol. Cisco proprietary though partially open now. Uses multiple metrics including bandwidth, delay, reliability, load. MTU, not part of metric but tracked. Administrator can weight these using the K values,
Cisco.
makes path selection far more flexible and intelligent. BGP Border
Leading the
Gateway
bit
Protocol,
industry.
used between
Okay.
ISPs and large networks. Exterior Gateway Protocol, not focused on internal dynamic metrics, chooses routes based on path attributes and policy, not bandwidth or
Oh, hey,
reliability.
man. How's it going?
5. Real-world scenario. You're managing a corporate network with a fiber connection, high bandwidth, a backup DSL line, low bandwidth, high reliability. With EIGRP, you can configure the system to prefer the fiber link due to bandwidth, but failover to DSL if fiber loses reliability. No other protocol among these gives you that flexibility. Final answer.
Yeah, man, the stream yesterday, it got brutal. I'm not gonna lie. Like, I got through all 8 of those sections, but I was like totally fried afterwards. We're definitely gonna have to go back and like look at like section 1.7, 1.8, and 1.5. Those are the ones that I struggle the absolute most on. But anyway, back to this stuff. Or also, I hope you're having a great morning. Back to this stuff. So the RFP is the routing information protocol. This is the one that counts the hops that I was talking about earlier. Okay, the OSPF is the opus shortest pathway. This is low broadband or low bandwidth, high cost, doesn't count for load and reliability. It's just picking the shortest physical path. This is the Cisco one, which is super awesome because it takes takes into consideration all these different factors. And the BGP is the border gateway protocol. It didn't really talk about it, but this is the one that considers like the country, its laws, all the things. Like if I want to communicate or do something in I don't know, Russia or Australia or just another country, this is going to put into consideration what we're doing, what we're talking about, and if there's any legal things that are going to hold it back, kind of thing. Don't ask me how that necessarily works because it's also the internet and you can get around a lot of different things, but that's essentially what it is. Okay, and it's not focused on like dynamics, metrics, or anything like that. It's just making sure that it upholds the law for the most part. Yeah, based off of policy. Okay, so real world scenario. We're managing a corporate network. We have fiber connections. We have backup DSL. Oh my God, that's gross. And then with our EIGRP, that is hard to say. We will configure the system to prefer the fiber link due to bandwidth, overload DSL if it loses reliability. How can I get these questions? Like these questions specifically for here, like that like this like what we're doing, like the study guide and stuff that we have. What you'll do is you'll go to CompTIA.com or CompTIA.org, which is right here. I can actually drop the link if you want. CompTIA.org, and it's a little confusing because I don't want to. I just doxed myself. Okay. Oh, actually, no, I didn't. I don't think it popped up. It's a little confusing because they have like multiple stores and stuff like that. They have like their main where you can go through and look at all the different types of trainings and stuff and like help prepare your career. They also have a spot where you can actually buy their study guides. It's the store. And then they have like the actual place like right here where you can schedule your exam. You can go down and here's my practice stuff. I have a lot of different trainings that I bought throughout the while. It is not free. It's not free. And let me just tell you right now, okay? If you're sitting here and you're thinking like, oh, well, I'm trying to do all this stuff and I'm trying to do it for free, don't. You will waste so much time trying to find something that is free, that is comparable, that you will be so frustrated. It is not worth watching a bajillion and 5 YouTube videos to get the one little ounce of information. Just think of the 80-20 principle. Find something whether it be a junior college or a course online or like CCNA or CompTIA. Now there are YouTube channels that do give out free questions that you can, if you're just looking for an abundance of questions because your test is coming up. Okay, that's one thing. But if you're wanting to actually study this stuff and you're wanting to actually go for it, you need to just go ahead and buy the study material. I don't want to sound like it's like a super privileged person or whatever, but the stuff is only about $100, $200 or so, depending on which package that you get, and if you buy the test with it. But it's so worth it because you get so much stuff with it. Here, I'll even return real quick. You get a progress thingy, and this is just a study guide for like study questions. This is not the labs. Like there's a virtual lab that you can get if you're doing the Network Plus, where it's kind of like PC building simulator, except it gives you scenarios of how to complete it and making sure that you're following all the correct paths and stuff. So I highly recommend that you just bite the bullet, figure it out to be able to do it, especially if it's something that you're wanting to do. If it is something that is going to benefit you and that you're just generally wanting to do, then you will figure out how to generate that amount of money in order to do it. I mean, people do it with college literally all the time because college is crazy expensive, right? But yet everybody wants the degree, everybody wants to go, and they figure out how to do it. Now, I'm not telling you to pull a loan out. There's no need to pull out a loan out for like $100. But like, save up your money. Don't buy that video game. Don't eat out for like a month or whatever. I get it. Things are expensive, but that's my 2 cents with it, because I was exactly like you. I went around and I was trying to find as many free things as I possibly could, and it just frustrated me because I wasn't getting the information I needed. And then when I actually bought the actual textbook and the actual stuff, I started progressing a lot faster. And in all reality, I think this and the test only cost me about $300 or so. Another little tip: you should definitely use the same email for all of this stuff. Don't use your school email. Okay, even if you're trying to get the student discount, you can get the student discount without making your account a student account, because this will stay with you for your whole life. Okay, enough of me talking about my high horse. Let's see what's going on with this. Let's go back to the question at hand.
A network uses a dynamic routing protocol that requires the administrator to provide weighted elements such as reliability, bandwidth, and load. Which routing protocol is being used by the network?
Okay, we just heard it. It is the Cisco proprietary, or partly proprietary. This cert and materials have too much return if you think like it's an investment. This cert and materials have too much return if you think like it's... Oh, sorry. It took me a second to understand. Yes. The return on it is like crazy. It's crazy. Anyway, let's go on.
A technician is reviewing the routing gateway protocols for the organization under the autonomous system as control as a single owner. In reviewing the available protocols, which one identifies routes within an as?
Okay, we're gonna do this as well. Next. Whoa. My fat fingers, dude. My keyboard is like crazy sensitive. And my keyboard at work is like not sensitive. Let's say choose two. I also highly recommend using some type of AI as a study thing. I shared this earlier, was my prompt. Whenever you're using AI as a tool, you should have it restate the question, give you a simplified answer, an analogy, an in-depth explanation, and then a real-world scenario, because it'll really help. It'll really help with the understanding of stuff. Ever so often it'll be like, hey, dude, you want us to make a chart? And you say yes or no, you know? All right, here we go.
An Interior Gateway Protocol, IGP, is the protocol that identifies routes within an AS. The time to live TTL IP header field reduces by 1 every time a packet forwards by a router, referred to as a hop.
Yeah.
The TTL output field in the ping command shows the counter's value when the packet arrives at its destination. Enhanced Interior Gateway Routing Protocol, EIGRP, is an advanced distance vector or hybrid routing protocol. EIGRP relies on neighboring routers to report paths to remote networks. The Routing Information Protocol, RIP, only considers a single piece of information about the network topology, which is the next hop router to reach a given network or subnet vector.
Okay, the only one we don't know what it is the IGP, which is the Interior Gateway Protocol. This is the protocol that identifies routes within the AS. The AS is the autonomous system. So let's see what Chatbot has to say.
Real-world example or scenario.
Okay.
Let's walk through it. 1. Restate the question. Which protocol is used to identify and manage routes within a single autonomous system as, meaning the network is under one organization's control? 2. Simplified answer. IGP Interior Gateway Protocol is the best answer. 3. Analogy. Imagine an autonomous system as like a large company campus. IGP is the internal GPS used inside the campus. EGP, like BGP, would be the system that connects between different campuses. 4. In-depth explanation. Let's break down each choice. IGP Interior Gateway Protocol. Not a protocol itself, but a category of routing protocols used within an autonomous system. Includes RIP, OSPF, EIGRP, ISIS. The question is asking for the type of protocol that manages internal routing. IGP is the correct term.
Okay, so basically this is the big thing that has all those other things inside of it. So it's an internal GPS used inside the campus. That's very interesting. Let's continue.
EIGRP, a specific IGP developed by Cisco, used within an AS. Technically correct, but not best if you're being asked for the type category of protocol.
Let's go down this rabbit hole.
RIP. Also an IGP, but it's old and limited. Correct type of protocol, but not the best overall answer when the broader category is available. TTL, time to live, not a routing protocol. TTL is a field in an IP packet that prevents it from looping forever. Each router decrements the value. 5. Real-world example. A company has 5 branch offices, each connected through routers. They want to manage routing within their company, same as. They use EIGRP or OSPF, both of which are IGPs. They do not need BGP, which is used to route between ISPs or separate ACs. Final answer, IGP Interior Gateway Protocol. Let me know when you're ready for the next question.
There's another one. I don't remember. Okay. So let's dive into this a little bit. Let's talk a little bit more about autonomous systems and how they relate to these other things and any others that I might have missed. Oh my God, dude, it's so hot in my room. Internal gateway. Go back and review this real quick. Not a protocol itself, but it's a category of routing protocol within the autonomous system. So these all must be autonomous systems, and then this is just a category inside of it, or all of these categories inside of it. And what is ISIS? All good questions. What do we got?
Great question. Let's break it down thoroughly so you fully understand what an autonomous system is and how it relates to routing protocols like IGP, EIGRP, RIP, OSPF, and BGP. 1. Restate the question. What is an autonomous system as, and how does it relate to routing protocols like IGP, EIGRP, RIP, and others? 2. Simplified answer. An autonomous system is a network or group of networks under a single administrative control, like a company or ISP, that uses a single routing policy. It uses IGPs like RIP, OSPF, EIGRP for internal routing, and EGPs like BGP for external routing between other autonomous systems. 3. Analogy. Think of the internet as a country made up of states. Each autonomous system is like a state with its own road system routing policy. Inside each state, local roads follow in-state rules, IGPs like OSPF, RIP, or EIZRP. Interstate highways connect the states together. That's BGP, the EGP.
Okay. Man, I love these analogies, dude. They just make everything make so much sense. Okay, so the autonomous system is like the states. It has its own roads. Inside each state is local roads that follow in-state rules, which is like the IGP, which is what right here. Okay. And all of the others. So that means all of these others are also the same thing. The interstate highways connected to the states together using BGP and EGP, which I'm not entirely sure what those are. We might ask what those are, unless it tells us in a second.
BGP, the EGP. 4. In-depth explanation. What is an autonomous system? AS, a collection of IP networks and routers under a single organization's control, identified by a unique autonomous system number ASIN. Example, Google, Amazon, or your local ISP all operate their own AS. Why do we need ACEs? The global internet has billions of IP addresses and thousands of networks. ACEs help divide routing responsibilities into manageable units. Each AS handles internal routing while communicating externally with other ACEs.
Interesting. So we have a little table here. Routing protocol relationship. We have IGP, which is what the answer was. Name RIP. Interesting. I don't understand how IGP relates to RIP. Simple. Oh, because it's uses for simple. Technician is reviewing routing gateway protocols for the organization under the anonymous system controls as a single owner, and reviewing the available protocols which identifies routes within an AS. So this is inside of RIP. Interior gateway. Cisco proprietary hybrid. Inside as, between ases. Okay. Because RIP counts the hops. But I thought RIP was also like old and like legacy. Advanced link state routing. ISP graded link state. Okay, tell me more. I want to know more.
How they work together. Within an AS, the company uses OSPF and IGP to manage internal traffic routing between branch offices and data centers. Between ACs, the company connects to its ISP using BGP, allowing it to send, receive data over the internet to, from other companies' ACEs. 5. Real-world scenario. You're a network admin at a large university. Your university network has 64,501 has 3 campuses, dozens of routers, hundreds of subnets. You use OSPF and IGP to route traffic between departments and buildings. A BGP connection to your ISP to send and receive internet traffic. This setup keeps internal traffic.
So it's making sure that it can manage the internal traffic and the external traffic, and then there's protocols for all the different layers. I know that sounds super redundant and like duh, but it just kind of clicked in my head. Kat, I need you to relax. Okay, so bonus visual setup map. So here's the university. Here's the IEGRP between routers. Here's the RIP for legacy subnets. Okay, I was right. RIP is legacy. So does that mean IGP is also legacy? OSPF in core. Here's the BGP, which goes to the outs. ISP is the internet. Interesting. Very interesting. So let's go back to what the actual question was asking.
A technician is reviewing the routing gateway protocols for the organization under the autonomous system as control as a single owner. In reviewing the available protocols, which one identifies routes within an AS?
So how does IGP and RIP correlate? Does that as well correlate? I feel like that's not right. Yeah, okay. Look, spelling and punctuation matters so much. I can't even express. How do you correlate and relate to each other? Okay, RIP is a type of IGP. IGP is a category, and RIP is one of the protocols. So RIP is a protocol. Okay, IGP is a category, and that is a category. This is a category. This is time to live, which is absolutely nothing. Which goes back to what we were talking about before, where every question always has a throwaway answer. Very rarely do questions, all of them, seem right. And it wants to know, a technician is reviewing a routing gateway protocols for the organization under the AS control as a single owner. So the AS is the single owner. In reviewing the available protocols, which identifies routes. So it wants to know, well, in reviewing the available protocols, which identifies routes. But this is not a protocol. How is that? How is this the answer? But it says right here, the internal gateway protocol. The protocol is even in its name. But you're going to tell me that IGP is the category and RIP is the protocol inside the category? But the name protocol is inside of the acronym. Okay.
4. In-depth explanation. What is IGP? Interior Gateway Protocol (IGP) is a broad category of routing protocols used within a single organization, or as. These protocols help routers exchange information so they can find the best path to a destination inside the network. What is RIP? Routing Information Protocol is one of the earliest and simplest IGPs. It's a distance vector protocol that uses hop count max 15.
Okay,
IGP.
That's why it's a category, because it is all of the protocols. I can make that make sense in my brain.
Five. Real-world scenario. You're managing a small business network with only 5 routers. You implement RIP because it's easy to configure and suits a small environment. RIP keeps each router aware of the number of hops to reach any destination. If the network grows, you'll consider switching to OSPF or EIGRP, which handle larger topologies better. So in this case, you are using an IGP. That IGP happens to be RIP, a simple tool in the internal routing toolbox.
Okay, let's go back to this. So IGP is the internal GPS used inside the campus. EGP, like BGP, would be a system that connects between campuses. Okay. So IGP is internal. No. What I don't understand is, why is it IGP and not this one? Or RIP, for that matter. Is it just because IGP is all of it?
Let's break down each choice. IGP, Interior Gateway Protocol. Not a protocol itself, but a category of routing protocols used within an autonomous system. Includes RIP, OSPF, EIGRP, ISIS. The question is asking for the type of protocol that manages internal routing. IGP is the correct term. EIGRP, a specific IGP developed by Cisco, used within an AS. Technically correct, but not best if you're being asked for the type category of protocol. RIP, also an IGP, but it's old and limited. Correct type of protocol, but not the best overall answer when the broader category is available.
So that's what it is, just test-taking skills, that this is the best logical answer because these are also IGPs. However, it's reviewing the protocol and it wants to identify the routes within it. This is going to have all of them. So this is the more correct answer. I'm not gonna lie, this is a dirty question. Moving on. Well, now that we're armed with like way more information, let's see if we can just figure this one out.
A network technician is looking at various administrative distances to see which route would take the longest. Which of the following would have the highest administrative distance?
Unknown. All right, we're gonna do the good old next question here. And while we do this, we're gonna have it read to us.
Unknown has an administrative distance of 255. An administrative distance add value expresses the relative trustworthiness of the protocol supplying the route. Routing Information Protocol RIP has an administrative distance of 120. Default add values are coded into the router but can be adjusted by the administrator if necessary. Open Shortest Path First OSPF has an administrative distance of 110. Each routing protocol uses its metric to determine the least cost path. Static has an administrative distance of 1. As routing protocols use different methods to calculate the metric, a network technician cannot compare routes from other protocols in the overall IP routing table using add values.
What we need to make sure we understand is administrative distance.
Great. Let's walk through this question clearly. Question. A network technician is looking at various administrative distances to see which route would take the longest. Which of the following would have the highest administrative distance? Correct answer. Unknown. Explanation. Administrative distance add is used by routers to choose between multiple routing protocols when they all offer a route to the same destination. The lower the add, the more preferred the route. The higher the add, the less trusted the route.
So administrative distance is not the distance between two offices like how I said earlier. It is the distance between point A and point B.
Here are the typical add values. Route type administrative distance connect.
Okay, I can make this make sense because I used to do drop shipping, and or eBay rather, when you're selling something on eBay and you have to charge for what's it called, shipping, you don't necessarily know where anyone's at. You don't know who's gonna buy from you. So there's like this standard practice that everyone uses the furthest distance away from you in order to determine shipping cost. Now, you want to do that because then that's going to make the shipping cost like crazy high, right? And what that's going to do is going to cover you for just about anybody. Now, good people, if I remember correctly, you can change this depending on the person. So then, like, if I'm selling I don't know, like a Digimon card, get a little visual here. Okay, if I'm selling this like super awesome Digimon card and I'm sending it to someone who's only a town away, I don't know that the person from a town away is going to buy it until they actually buy it. So when they go and they see the shipping cost, it's going to be astronomical. But then when they actually go through the process, it should theoretically knock down because now I have the exact location. And I don't look like a heel because I said it was going to be really cheap, and then all of a sudden it's really expensive. I said that it was going to be really expensive and it was going to be really cheap. Okay? All right, moving forward.
Connected interface 0, static route 1. EIP internal 90 OSPF, 110 RIP 20 unknown. Internal. So among the choices, static equal to 1, OSPF equal to 110, RIP equal to 120, unknown equal to 255, highest and not used at all. Final answer, unknown administrative distance equal to 255, highest and the router will...
And I'm pretty sure administrative distance is calculated the same exact way that like it uses similar math like subnets and stuff. That's why it's 255. Here. What is administrative distance and explain it. As soon as we understand administrative distance, we should be cooking. Administrative distance is the number of a route uses to decide which routing source to trust more when multiple sources like RIP and OSPF, static routes, offer paths the same distance. The lower the number, the more trusted the source. So analogy, imagine you're planning a trip and you get just directions from 3 different people: your best friend, a stranger, and someone who's known to lie. Administrative distance is the numerical value of the routing protocol or method that tells the route how trustworthy each source. So how do they calculate it? That's what I want to know. You're managing a network. Route receives the same routes from 2 sources. Here and then here, the route will ignore and then use the static route. Also will manage traffic too, I would imagine. AD is a trusted source for routes. Low equals better. Never trust this route. Okay. But how is administrative distance calculated? This has nothing to do with anything. This is literally the last 20% of the 80-20. I already have enough information to answer the question. I just want the last, like, I need to know. It's not calculated, it's assigned. Oh, administrative distance is, okay. Oh, I know it's the preferred value, but where do you get that value from? Given by the router's operating system, like Cisco's iOS, to each type of route source. You can manually change it but by default it is fixed. Oh. Think of AD like a ranking system, 0 to 255, where each route source has a pre-assigned trust level. It's like a classroom where the teacher has already given certain students a most trusted label. You don't calculate it. You look it up and opportunely override it. I don't really like that analogy. As a teacher, has already given certain students a, well, I mean, I guess there are definitely students who I trust more. I wouldn't necessarily say that I label them. I don't want to get down in the weeds though. Okay. Administrative distance is not dynamically calculated based on metrics or real-time performance. Instead, it's a static value assigned to routing protocols, static routes, direct connection routes, external routes. So, okay. Direct connected routes. And I'm sure that it's assigned this stuff based off of the amount of hops it has to do and the amount of places it has to go. I don't necessarily know how it got 90, but it did. Interesting. Okay. We don't need to go further with that. Let's keep going.
A network contractor is reviewing the algorithms used for path selection. The algorithms categorize according to the topology and metrics used to build and update a routing information base. It also prioritizes optimal or least cost paths. What algorithm uses the number of hops to determine the destination as a metric?
Which algorithm uses the number of hops to determine the destination as a metric? Distance vector? Ooh. I mean, I got it right, but why? Okay.
Distance vector protocols use the number of hops to the destination as the metric. The route with the fewest hops is the least cost path, and the network will select it for use. Static routes configure as non-persistent or persistent permanent. A non-persistent route is removed from the routing table if the router gets rebooted. The Routing Information Protocol, RIP, is a distance vector routing protocol. RIP only considers a single piece of information about the network topology, the next hop router to reach a given network or subnet vector. Hybrid Routing Protocol is an advanced...
So why is it distant vector and not routing protocol? Did I miss it? Distant vector protocols use the number of hops in the destination as the metric. The route with the fewest hops is the least cost path, and the network will select it for use. RIP is a distance vector. Oh, this is just like how the other one was. It's a distance. So it's asking for the algorithm that uses the number, which is a distance vector. RIP uses distance vector. Okay. What algorithm uses the number of hops? What algorithm, not protocol?
Which statement is true regarding the configuration of routers in a FHRP setup?
I want to make sure that I understood this. I explained it, but I felt unconfident with it. First hop redundancy protocol. Okay, that's also what I wanted to know. I want to know this acronym. There's so many freaking acronyms, dude. It's ridiculous.
Correct answer.
Oh.
Each router must have a unique MAC and IP address, but they share a common virtual IP address. Explanation. This question is about FHRP, First Hop Redundancy Protocol, which includes protocols like HSRP Hot Standby Router Protocol, VRRP Virtual Router Redundancy Protocol, GLBP Gateway Load Balancing Protocol.
Look, I've said it before. The problem with AI is that it doesn't stop learning. I don't want it to change what I'm doing. I want it to be a mindless drone. If I set it up to do something, I want it to only do that thing. Okay, we'll read this and then we're going to keep going.
Key concepts. In an FHRP setup, multiple routers are configured to back each other up for a default gateway.
Yes.
They each have their own unique IP and MAC addresses,
Yes.
but they share a common virtual IP address, and sometimes a virtual MAC that client machines use as their default gateway. Only one router is active at a time depending on protocol, responding to the virtual IP. If the active router fails, another takes over seamlessly.
Yeah.
Absolutely. Here's the 5-part format answer for your
Oh, it's still
FHRP
going.
question. Question restated. Which statement is true about how routers are configured in a first hop redundancy protocol FHRP setup? Simplified answer. Each router must have a unique MAC and IP address, but they share a common virtual IP address. Analogy. Imagine a group of substitute teachers sharing one desk nameplate that says Mr. Gateway. Each substitute has their own ID and email MAC and IP, but whichever one is currently teaching uses the shared nameplate so students don't have to memorize a new name every time one is replaced. In-depth explanation.
That's funny.
FHRP, First Hop Redundancy Protocol, is designed to eliminate a single point of failure for a network's default gateway. This is especially important for local networks, where hosts need a consistent gateway to reach external networks. Here's how it works. Each router in the FHRP group has its own unique IP and MAC address. They share a single virtual IP address, and sometimes a virtual MAC address, known as the virtual default gateway. This virtual IP is configured on hosts as their default gateway. One router is elected as the active router or master, depending on the protocol. If the active router fails, another router in the group automatically takes over, ensuring seamless traffic flow. Common FHRP protocols: HSRP Cisco Proprietary, VRRP Open Standard, GLBP Cisco Proprietary with load balancing features. Each protocol implements this concept slightly differently, but follows the same core principle of virtual redundancy. Real-world scenario. Your company has 100 workstations using 192.168.1.1 as their
I
default
hate when
gateway.
it reads IP
Instead of
addresses.
manually changing this IP when the gateway router fails, you configure HSRP with two routers. Router A, 192.168.1.2. Router B, 192.168.1.3. Virtual Gateway IP, 192.168.1.1. If Router A, the active router, goes offline, Router B detects the failure and takes over the virtual IP, and users never notice the change. No reconfiguration needed. Would you like a visual diagram of an FHRP setup, or are you ready for the next question?
No, I'm definitely ready for the next question. I want to make sure that I memorize these, though. HSRP is Cisco Proprietary. I knew that. The VRP, I did not know that was open standard. And then the GLBP is Cisco Proprietary, but it includes load balancing features. Very interesting. Very interesting. I had something I was going to say about this, but I do not remember what it was, so it must not have been important. So basically, the FHRP, which is something redundancy protocol. First hop redundancy protocol, making sure that things are always up and running. So the router must have a unique MAC and IP address, but they can share virtual IP addresses. This was the one that I was like, I know that it's the neighbor discovery protocol, but I don't remember why. Like, I don't remember what it is. Next question. And then get rid of all the unselected. Correct. Okay, I'm gonna let my cat in real quick. Oh. Oh my god, dude, it's so hot in my office. Uh-oh, my thread's starting to get pretty long. It's having a hard time. Let's see if we can get through all of section 2. Probably not. We'll probably have to stop it somewhere along the way. All right, here we go.
Great. Here's the 5-part breakdown for this IPv6 routing question. Question restated in an IPv6 network. Which protocol is responsible for letting a host know that a better route is available when sending packets? Simplified answer. Neighbor Discovery Protocol (ND) is the protocol that facilitates this functionality. Analogy. Imagine you're driving using GPS and your device suddenly says, faster route found, rerouting. That's what ND does for your IPv6 device. It learns about a quicker or more optimal path through a router update. In-depth explanation. Neighbor Discovery Protocol (ND) is essential for IPv6 networks. It replaces several IPv4 protocols like ARP, ICMP router discovery, and RARP with a more robust unified system. Here's what ND handles. Router discovery, finding routers on the network. Prefix discovery, learning what subnet you're in. Parameter discovery, getting things like hop limits and MTU. Address resolution, finding MAC addresses for IP addresses. Better route discovery, learning of alternate or improved routes. This is your case. ND uses ICMPv6 messages, and 2 of the most relevant here are router advertisement RA, sent by routers to inform hosts about prefixes and default gateways. Redirect message, part of ND, sent by routers to inform hosts of a better next hop router for a particular destination. So while RA is part of ND, it's the neighbor discovery protocol as a whole that enables the router to tell the host about better routes. Real-world scenario. You have a laptop with IPv6 configured. You try to send a packet to another part of your company's network. Initially, your laptop sends it to the default router. But that router sees a better route through another router in the network and sends a redirect message via ND. Your laptop then adjusts its routing table to send future packets directly through that better path. Would you...
Interesting. Okay, so I'm noticing a pattern where we always have... There's our throwaway. This is also a throwaway. This is... So it's like it's different degrees of like throwing away. So we have the the dynamic host configure protocol. Like that has nothing to do with anything. Dual stack at least has something to do with IPv6. And then we have the router advertisement, the raw, and that is actually inside of the neighboring discovery protocol, which is IPv6. Okay, let's keep going.
Which networking protocol provides routing capabilities on the internet, primarily between internet service providers ISPs?
The BGP. No. Yes. Yes.
A network administrator is troubleshooting network routing issues in the lab. The layer 3 switches in the server room have multiple routes for each subnet. The issue only needs to be temporarily resolved for a scheduling test today. How can the network administrator temporarily fix this routing issue?
Okay, so the network administrator is troubleshooting a network routing issue. So we have a routing issue in the lab. The layer 3 switch, see, I told you it's always going to say, like if it's a switch and it's layer 3, it'll always say it. It'll always say it. A layer 3 switch in the server room have multiple routes for each subnet. The issue only needs to be, so what's the issue? So the issue is that the layer 3 switch has multiple routes. The issue only needs to be temporarily resolved for a scheduled test today. So we need to configure internal gateway protocols, configure default routes, configure a static route, configure an external gateway protocol. I'm going to say static route. Yeah, that makes the sense. That makes the most sense. One, the static route has an administrative distance of 1, so it's going to be the shortest path. Okay. 2, static means that you're manually putting it in, and then because it only needs to be a temporary fix, so I don't really need to do anything else.
Which statement is true regarding the configuration of routers in a FHRP setup?
Something hop redundancy protocol. And the answer is that they must have different MAC and IP addresses, but they share a virtual IP address. We already talked about that.
A host uses Internet Protocol version 6 IPv6. The host sends a packet to another host, and a router informs the host of a better route to take. Which protocol facilitates this function?
Because neighboring discover protocol is IPv6, and it eliminates a bunch of crap from IPv4.
A company's network monitoring software alerts to issues where packets are circulating between two routers before they get discarded. How would a network administrator confirm this routing issue on the network?
Company's network monitoring software alerts. Oh, okay, it's alerting to an issue, but we don't know if that's real or not. Wait, yes we do. Where packets are circulating between two routers before they get discarded. How would a network administrator confirm this routing issue on the network? Check the router's next table for the next hop. Check the ISP and the two ISP routes. Okay, a company is monitoring software alerts to issues where packets are circulating between two routers before they get discarded. How would the administrator confirm this routing issue on? I would say that they would look at they would ping it and they would do time to live. Yeah. I don't know why I overthought that question so hard.
A network architect has positioned multiple routers in different floor levels of a 10-story office building that will support the internal network of a large software company. Each routing device has redundant paths and connections. Which routing protocol would best benefit the organization's hierarchical structure?
Ooh. It is either the... Oh, man. Okay, so this is one that I can make an argument for just about all of it, except for this one. This is the throwaway. The RIP, which is going to be... It's just going to... Well, no. I can't make an argument for that one. I already defeated it. It's legacy. It's not going to work. Okay? Actually, I could make an argument for it because it's a building which supports an internal software of a large software company. Okay. Large gets rid of this. If it wasn't large and it said small, then I would say, yeah, sure, maybe it's ARP, or RIP. Now it's just a matter of the OSPF or the EIGRP. The main difference between is that one does load balancing, one doesn't. I'm going to go with this one. So then it was OSPF. What do we got?
Why is convergence important in a dynamic routing environment? It allows routers to adapt to network changes such as failures or additions. It decreases the overall security of the network by sharing routing information. It ensures that routing tables are manually updated in a timely manner. It prevents the manual configuration of network devices.
So why is the...
Why is convergence important in a dynamic routing environment?
So it allows routers to adapt to network changes such as failures or additions. It decreases the overall security of the network by sharing routing information. It ensures the routing tables are manually updated. Why is convergence important in dynamic routing environments? So this is saying that it ensures manual. This says that it prevents manual. This has nothing to do with manual. I don't know. I don't know.
A network manager configures a dynamic routing protocol on the company network. The protocol considers only one route to a given destination network. To prevent looping, the protocol limits the number of hops to 15. Which of the following protocols is the manager is implementing?
The manager configures a dynamic route protocol network. The protocol consists of only one route to a given destination. RIP. The reason I knew it was RIP is because the protocol limits the number of hops, and RIP limits the number of hops.
A network architect has positioned multiple routers in different floor levels of a 10-story office building that will support the internal network of a large software company. Each routing device has redundant paths and connections. Which routing protocol would best benefit the organization's hierarchical structure?
Okay, so my question is why is it this one?
Open Shortest Path First OSPF is a link state type of routing protocol ideal for hierarchical systems and networks. OSPF is suitable for organizations with multiple redundant paths between networks.
Why is it not this one?
Enhanced Interior Gateway Routing Protocol, EIGRP, is a distance vector, or hybrid routing protocol. It relies on neighboring routers to report paths to remote networks, and uses a metric composed of administrator-weighted elements.
I do think that that's not necessarily ideal for the scenario, and I'm sure like that's why this is the correct answer, but I want a better reason. What is it? OSPF. EIGRP. And then I can just get rid of this other crap. Yeah, I'm gonna need a new thread here soon. This is, yeah. Yeah. After this
Great.
section,
Let's break it down in your 5-part format to fully explain. Simplified answer. OSPF Open Shortest Path First is designed for large hierarchical multi-area networks, making it the best choice here. EIDRP is powerful but proprietary and not as scalable across structured multi-area environments. Analogy. Imagine building a massive library with 10 floors. You want each floor or area to manage its own catalog of books but still connect efficiently to the rest. OSPF lets you split your network into areas and manage routes cleanly, like giving each floor a local librarian while still keeping a global directory. ERP, while fast and smart, acts more like one massive central librarian trying to manage everything. Okay. It works but gets inefficient as things scale. In-depth explanation. Why OSPF fits. Open standard, works across all vendors, Cisco, Juniper, etc. Supports hierarchical design. You can break the network into areas with a backbone area 0 to reduce complexity and routing overhead. Scalability, ideal for large enterprises with many routers and subnets. Link state protocol, each router has a full map of the network, allowing fast convergence and precise path calculation. Why not EIDRP, even though it's good, proprietary mostly? Traditionally Cisco only, though newer versions are more open, but still not as universal. Flat design by default, EIDRP doesn't natively support a multi-area hierarchical design like OSPF.
Okay.
Better suited for simpler or smaller topologies. It's fast, but not built with strict hierarchy in mind. Real-world scenario. A software company spreads its IT infrastructure across 10 floors. They need clean segmentation for departments, redundancy, and fast failover. Using OSPF, the architect can place each floor in its own OSPF area, Area 1, Area 2, etc., all connecting to the backbone Area 0. This design reduces routing table size, speeds up convergence, and isolates problems to specific areas, something EIGRP can't do as elegantly. Would you like to compare OSPF areas and design next, or should we move on to the...
Okay, that makes sense. Continue. This is the one that I straight up didn't even know. Next question. Yeah, and the more I ask it, the harder it's gonna work to get these going. All right, let's see what this has to say while we wait for it to generate.
Convergence is crucial in dynamic routing because it enables routers to quickly adapt to changes in the network, such as new network segments being added or existing ones failing. This adaptability ensures that data can be efficiently routed through the network despite these changes. Convergence is an automatic process, not a manual one. Convergence does not prevent manual configuration. It's about routers automatically adapting to changes. The purpose of convergence is to maintain efficient routing, not to affect network security.
I guess I don't understand what convergence is. Like, I know what the word convergent means.
Let's break it down using a simplified answer. Convergence allows routers to quickly adapt to changes like outages or new routes by updating their routing tables automatically. Analogy.
Because it converges to the new route. Okay, that makes sense. I can use my understanding of what the definition of that word means.
Think of a city with live GPS navigation. If a major highway closes due to an accident, GPS apps reroute traffic through side streets to avoid the jam. That rerouting is convergence, a system adapting quickly to real-world changes. Without it, you'd be stuck with outdated directions and traffic chaos. In-depth explanation. Convergence is the process where all routers in a network agree on consistent routing information after a change. In dynamic routing, protocols like OSPF, EIDRP, and BGP are constantly learning and adapting. When a link fails, a new device is added, or a route changes, convergence ensures all routers recalculate paths and synchronize their routing tables.
Wow.
Fast convergence equal to less downtime, better reliability, and smoother traffic flow. Without convergence, packets could be dropped, misrouted, or looped. Real-world scenario. Imagine a data center network where a switch fails. OSPF detects the failure, recalculates the best paths, and updates all routers within seconds. Your cloud app stays online, and no one notices. That's the power of convergence in action.
Wow.
Correct answer.
I don't want to derail us too hard with stuff, but the more I learn about technology, data, network, how coding works, how to create programs, bots, AI, the more I learn all about all that stuff, the more I'm convinced that we are a simulation. I'm not going to talk any more about that, so you can just kind of let that be in the back of your mind, kind of, you know? Yeah. So why is convergence important in a dynamic routing environment? It allows routers to adapt to new changes such as failures and additions, and then it allows them all to sync up.
A network uses a dynamic routing protocol that requires the administrator to provide weighted elements such as reliability, bandwidth, and load. Which routing protocol is being used by the network?
Enhanced Interior Gateway Routing Protocol. We already talked about it a lot.
A technician is reviewing the routing gateway protocols for the organization under the autonomous system as control as a single owner. In reviewing the available protocols, which one identifies routes within an as?
IGP. IGP is all of the protocols.
A network technician is looking at various administrative distances to see which route would take the longest. Which of the following would have the highest administrative distance?
Unknown, which has the max. Static is 1. RIP is like 120. OSPF is like 90.
A company's office building has the network segmented into different areas based on floor level. The network architect is working on building a hierarchical routing network to take advantage of multiple redundant paths between each network segment. Which routing protocol will the architect most likely implement in this network?
So if it's going to take redundancy paths, company's office building has a network segment into different areas. It's got to be OSPF. It's not going to be RIP because it's not about redundancy. It's not going to be BGP because it's talking about internal. It's not going to be this one because it's not large enough.
A network administrator is maintaining a lab network, including several routers using open shortest path first OSPF. The administrator adds a specific route to a new router. Which default value will this new route be assigned for administrative distance?
I'm pretty sure it's 90. Then it must have been 110.
Why is convergence important in a dynamic routing environment?
It allows routers to adapt to network changes such as failures and additions, and then also additionally, it allows them to sync up to make sure that they all agree on everything.
A network contractor is reviewing the algorithms used for path selection. The algorithms categorize according to the topology and metrics used to build and update a routing information base. It also prioritizes optimal or least cost paths. What algorithm uses the number of hops to determine the destination as a metric?
RIP, routing information protocol. What? Distance vector. What algorithm? What algorithm? Not protocol. Algorithm. Yeah, I was 110. This is just like the port numbers. Like, you just got to memorize them. Like, there's so much of this stuff that you just kind of have to like memorize. You just have to like accept it in your heart. Like, this is the answer. Okay, what's 20? Border gateway protocol. What's 90? Oh, that's the EIG RP. Okay, next. Yep.
A network architect has positioned multiple routers in different floor levels of a 10-story office building that will support the internal network of a large software company. Each routing device has redundant paths and connections. Which routing protocol would best benefit the organization's hierarchical structure? A lab network has different routers to mimic a wide area production network. The lab network is segmented into sections, such as development, staging, and pre-production. By default, if the router specifies a static route, then that route gets which administrative distance value?
1.
A network contractor is reviewing the algorithms used for path selection. The algorithms categorize according to the topology and metrics used to build and update a routing information base. It also prioritizes optimal or least cost paths. What algorithm uses the number of hops to determine the destination as a metric? Smart Refresher 2.1 explain characteristics. A network contractor is reviewing the algorithms used for path selection.
Same question. Algorithm. OSPF. That one is 90. Buddy! It's 110. What's 90? Ugh, I got... What is it looking at? Default static route is 1. It's 90. Did I just make the same mistake with you? Static route is 1. Is 110. Got it wrong 3 times. Okay. Before we move on, I am going to fix up ChatGPT real quick. A lot of times when you use AI, you always have to ask it, like, do you understand? That's why I have it restate the question. Because, oh, come on. Because I need to know that it understands. There are some times when, like, you'll ask it a question and it will, it'll just make up random crap. It has nothing to do with what you're doing. So, like, if that's like my like redundancy, I guess. If it restates the question completely different or makes up a completely different question, then I know that something's wrong. You know, that's why I have it restate the question. I also have it restate the question for being able to recognize the scenario, you know? All right, let's see how this goes.
Leaf topologies to connect distribution switches to server nodes and provide higher bandwidth than the typical workgroup switch.
Which of the following is a model typically used in the spine in leaf topology to connect distribute switches to serve nodes? Not fiber channel. I feel like we learned what fiber channel was. Hold on, just read it again.
Answer. Which of the following is the model typically used in spine and leaf topologies to connect distribution switches to server nodes and provide higher bandwidth than the typical workgroup switch? Answer. Top of rack switching, core, fiber channel, software defined network.
I'm pretty sure it's core. Nope.
What happens when an 802.1Q tagged frame is received on an untagged port?
Oh, man, I know this. The frame is dropped. The frame is forwarded with the tag. Tag is stripped and the frame is forwarded to the host. I'm pretty sure that's the answer. Yes.
An engineer notices a large number of frames traversing a network. While frames are not getting dropped, the traffic from the frames is taxing switches in a network closet. What will the engineer most likely implement to resolve this issue?
Engineer notices that large number of frames. Jumbo frames. Yeah.
A network engineer configures network connectivity. Identify how switches will work if the engineer configures the spanning tree protocol STP.
Switches are organized into a hierarchy. Spanning tree protocol. Each switch determines the shortest path to the root. Hosts can configure IPv6 address automatically. Hosts are allowed to discover other nodes. Each switch determines the shortest path to the root. I don't remember spanning tree protocol. Okay, I was wrong.
Which of the following describes a technique that constitutes a form of link aggregation?
Man, I remember these terms. NIC teaming means that you're using a whole bunch of NICs. Like they're like literally as it sounds, it's teaming up. Technique that consists a form of link aggregation. Load balancing? No.
When implementing jumbo frames, what is crucial to ensure among all hosts and appliances along the communications path?
That they use a fixed error checking. They support standard Ethernet size, bytes, MTU. I'm pretty sure it's this one. No, dang, dude. It is not going well.
A network consultant reviews protocols to determine if bonded links between the switch ports and the end system were auto-negotiated. What is the name of this protocol?
To determine if bonded links between the switch port and the end system were auto-negotiated. Okay, I want to know what... I'm pretty sure it's LACP, but I don't know what that is. I just use process of elimination.
An engineer configures a voice over IP VoIP implementation on an existing data network. What approach does the engineer use while avoiding the use of trunk ports? Select 2.
Auxiliary VLANs and multiple broadcast domains. Yeah. All right.
Top-of-rack switching refers to the practice of using switches specifically made to provide high bandwidth links between distribution switches and server nodes. A software-defined network does not serve the purpose of connecting server nodes to distribution switches. The software-defined network makes all parts of the network infrastructure accessible to automation and orchestration technologies. Fiber Channel FC connects storage area networks via fiber technologies, not server nodes and distribution switches. Fiber channel involves 3 components: the initiator, the target, and the FC switch.
Yes.
The core is a layer of the hierarchical network model that provides a highly available network backbone. This layer comprises connections between wide area network WAN routers, firewalls, and layer 3 switches.
Okay.
Great. Let's break this one. Restate the question. Which network model is typically used in spine and leaf topologies to connect distribution switches to server nodes, offering higher bandwidth than a standard workgroup switch? 2. Simplified answer. Top-of-rack switching is the correct model typically used in spine and leaf architectures to connect servers efficiently and provide high bandwidth. 3. Analogy. Imagine a massive warehouse with rows of shelves, servers. Instead of running cables all the way to a central office every time you need to connect something, you place a small control station switch at the top of each rack. That station connects locally and routes data quickly, reducing clutter, increasing speed, and streamlining operations. That's what top-of-rack Tor switching does in data centers. 4. In-depth explanation. Spine and leaf topology is a modern data center architecture where leaf switches connect directly to servers and to spine switches distribution core layer. Every leaf switch connects to every spine switch to reduce bottlenecks. Top-of-rack Tor switching means placing a switch directly at the top of a server rack, allowing short cable runs from each server to the switch. These Tor switches then connect upstream to spine switches. This setup is scalable, high bandwidth, efficient in cabling, minimizes latency. In contrast, Core refers to the central backbone of traditional enterprise networks, not specific to Tor. Fiber channel is a storage network protocol, not typically used for standard server connectivity. Software-defined networking (SDN) is an architecture for centralized control, not a physical topology like spine and leaf or a model like Tor. 5. Real-world example or scenario. In a large cloud data center like AWS or Google Cloud, each server rack has a Tor switch. These Tor switches are connected to multiple spine switches, forming a spine-leaf architecture. This allows any server to communicate with any other server across racks with minimal latency and maximum throughput, essential for handling millions of simultaneous data transactions. Let me know when you're ready for the next question.
Okay, so here's our spine and switch. Here's our leaf switch. spine switches, leaf switches, and then our end devices. This is a great website too if you're studying CCNA. Study-ccna.com. Really, really, really good website. I think I understand.
Top-of-rack switching refers to the practice of using switches specifically made to provide high bandwidth links between distribution switches and server nodes. Which of the following is the model typically used in spine and leaf topologies to connect distribution switches to server nodes and provide higher bandwidth than the typical workgroup switch?
Okay, next.
When implementing jumbo frames, what is crucial to ensure among all hosts and appliances along the communications
I thought it was
path?
that, but I couldn't remember what the stupid acronym for MTO is.
When implementing jumbo frames, it is critical that all hosts and appliances, switches, and routers along the communications path support the same MTU to ensure compatibility and proper functioning. The other options are incorrect, as they do not directly relate to the implementation requirements of jumbo frames.
But what is MTU? The maximum transmit unit. Dude, like, I'm telling you, these acronyms, they're going to be the death of me. I understand why they exist. And normally I would say acronyms are really stupid and they have no business existing. These matter, okay? But, like, if I would have known what that acronym was, then, like, yeah, I would have understood. Maximum transport unit, right? Transmission. So when implementing jumbo frames, what is critical to ensure among all the hosts and appliances along the communication paths? They all support the same maximum transmission unit, which would then be jumbo frames.
A network engineer configures network connectivity. Identify how switches will work if the engineer configures the spanning tree protocol STP.
See, again,
Select
like
2.
if I would have just known if I would have just remembered what spanning tree protocol is, or has a hierarchy of switches, then I would have got this. Switches are organized in a hierarchy, done. Each switch determines the shortest path to the root, done. Hosts can configure IPv6 addresses automatically. I have no idea. That has nothing to do with anything. Hosts are allowed to discover other nodes. I mean, I guess that doesn't really have anything to do with it. What really matters is that they determine the shortest path. Not that they discover new nodes. I mean, maybe they do.
Which of the following describes a technique that constitutes a form of link aggregation?
Oh, I even defined what that was when I did it. I was like, it can't be Nick. It can't be Nick teaming. Nick teaming is when they come together, aka are aggregating together in order to link together. Stupid. I'm stupid.
Link aggregation means combining two or more separate cabled links into a single logical channel. When done from the host end, this is called NIC teaming.
Yes. Okay. Let's solidify this in my brain here.
A load balancer can switch client traffic to alternative processing nodes, reducing bottlenecks and allowing for failover services in the event of a host or network route going down. A cluster is a group of servers, each of which is referred to as a node, that provides redundancy and fault tolerance for critical applications. A redundant circuit is two separate power supply lines from electricity suppliers.
That makes sense.
Great. Let's break down this question in full detail. 1. Restate the question. Which of the following is a technique that qualifies as a form of link aggregation, where multiple network connections are combined to act as one? 2. 3. Analogy. Think of traffic on a highway. Instead of sending all cars' data down a single lane network connection, you open up multiple lanes. NIC teaming is like opening more lanes and directing traffic across all of them to improve flow and reduce congestion, while still acting as one big road from the driver's perspective. 4. In-depth explanation. Link aggregation is a technique where multiple physical network interfaces or links are logically combined to increase bandwidth, provide redundancy, and ensure high availability. NIC teaming, also known as load balancing, failover LBFO, involves joining two or more network interface cards, NICs, on a host into a single virtual interface. This allows load balancing traffic distributed across links failover. If one NIC fails, traffic reroutes through the other. Let's quickly clarify why the others are incorrect. Load balancing is a broader term. While NIC teaming may perform load balancing can also occur at other layers, for example, application level, and doesn't necessarily mean link aggregation. Clustering refers to multiple systems working together, usually for failover or performance, not specifically network link aggregation. Redundant circuits imply backup links for failover only, not active aggregation of bandwidth like link aggregation provides. 5. Real-world example or scenario. In a server environment, an administrator might configure NIC teaming on a Windows server using two 1 Gbps NICs. The system sees a single 2 Gbps virtual NIC, improving throughput. If one NIC cable is unplugged or the switch port fails, the server keeps communicating using the remaining NIC, seamless to the end users. Let me know when you're ready for the next question.
All right, let's go to the next one. Okay, I knew this, but I didn't understand. Like, I don't remember why I knew this. What happens when 802.1q tagged frames received on an untagged port? The tag is stripped and the frame is forwarded to the host.
When an untagged port receives an 802.1q tagged frame, it strips the tag before forwarding the frame to the host. This is because the host connected to an untagged port is not expected to understand VLAN tags. The frame is not forwarded.
There it is. That's what I want to know. Not expected to understand VLAN tags. The frame is not forwarded with the tag intact. The tag is removed. Is not dropped. It is processed and removed the tag. Okay. I don't know why a frame would be tagged with this. But the tag is stripped and the frame is forwarded to the host. I want the analogy. I want to know what the analogy is. I don't know if it's going to read. Actually, I just want the analogy.
Three. Analogy. Imagine you're trying to enter a building using a VIP badge 802.1q tag, but you're at the normal guest entrance untagged port. The guard switch isn't trained to process VIP badges at this door. Instead of letting you in, he turns you away. That's what happens. The system rejects the tagged frame. 3. Analogy. Imagine you're trying to enter a building using a VIP badge 802.
Well, that is counterintuitive to what it is. It says the tag is stripped and the frame is forwarded to the host. Oh, the person who's trying to send it. Because it's not configured to interpret it, drops the frame by default to prevent VLAN leakage or misrouting. Let's say a server. Yeah, let's do the real work. I just want to understand it better.
5. Real-world example or scenario. Let's say a server connected to a switch sends a VLAN 100% tagged frame. That server is plugged into a port configured as an untagged access port, VLAN 1. Since the switch isn't expecting a tagged frame on that port, it drops the frame, and communication fails. This is a common VLAN misconfiguration issue, especially in mixed environments where trunk and access ports are not properly defined.
Okay. I just heard thunder. I have to mow my yard later. I'm gonna be very, very upset if it rains. Actually, before I put it in there, let's just see. Let's try again.
Link Aggregation Control Protocol LACP, which can be used to auto-negotiate the bonded link between the switch ports and the end system, detects configuration errors and recovers from the failure of one of the physical links. A switch learns MAC addresses.
Okay. Link Aggregation Control Protocol. See? You just gotta know the acronyms, man.
A network consultant reviews protocols to determine if bonded links between the switch ports and the end system were auto-negotiated. What is the name of this protocol?
Okay.
An engineer configures a voice-over IP VoIP implementation on an existing data network. What approach does the engineer use while avoiding the use of trunk ports? Select 2.
What approach does the engineer use while avoiding the use of trunk ports, multiple broadcast domains? Okay, this makes sense.
Most switches now support the concept of a voice or auxiliary VLAN, virtual LAN, to distinguish a PC data and VoIP traffic without having to configure a trunk. A VLAN, virtual LAN, creates its own broadcast domain. Therefore, the engineer uses multiple broadcast domains when integrating a data and voice network with VLANs.
Okay, most switches now support the concept of voice or auxiliary. Okay, VoIP. Okay. Well, I'm glad that happens because everything is like VoIP now. Okay, let's keep going.
Which of the following are examples of link aggregation, NIC teaming?
Connecting a computer to a wireless network and a wired network simultaneously in the internet? Maybe. Okay, using a single 10 gigabyte port to connect? No. Bonding 2 uplink, combining 1 gigabyte to create. Dang. Oh, I know this one was correct though.
Which of the following describes a technique that constitutes a form of link aggregation?
That's going to be NIC teaming. Because none of the other ones make sense.
A network technician needs to set up the ability to auto-negotiate a bonded link between the switch ports and the end system. Which of the following should they set up?
An auto-negotiating a bonded link between switch ports and end systems. Needs to set up the ability to auto-negotiate. I just went over that. Aggregate. I'm pretty sure that's the answer. Yes. But what does it mean? Is it link aggregate something protocol?
A sysadmin has set a network switch to auto-negotiate. What does this setting impact?
Sysadmin has set the network switch to auto-negotiate. That should impact speed. And if speed's the wrong answer, then it's aggregation. But I'm pretty sure it's speed. Yes. Because it's going to make it go faster because it's doing it auto.
A network engineer configures network connectivity. Identify how switches will work if the engineer configures the spanning tree protocol STP.
An engineer configures network connectivity. Identify how switches will work if the engineer configures the spanning tree. The hosts are allowed to discover nodes. I mean, maybe. The switch is going to be organized in a hierarchy, sure. Can configure IPv6, has nothing to do with it. Each switch is determined the shortest path, yes.
A network manager is designing a network for a new company. The company will have over 300 hosts and will interconnect multiple switches to build a network fabric. What will the network manager use to connect the switches?
Network manager Designing a network for a new company. The company will have over 300 hosts. It will interconnect multiple switches to the building and network fabric. What will the network manager use to connect the switches? Oh, it's just going to use VLANs. No? Is it trunks? I'm not gonna lie, dude. I have a hard time understanding trunks too.
Which of the following is the model typically used in spine and leaf topologies to connect distribution switches to server nodes and provide higher bandwidth than the typical workgroup switch? While deploying a VoIP network for a small business, a telecom company configures which options?
Auxiliary VANs, VLANs, multiple broadcast domains. Circuit-based transmission, no. Untagged frames. Okay, connecting computers to a wireless network and a wired network simultaneously. That makes sense because that's what a NIC is. I should have picked that. What do we got?
The following are examples of link aggregation, NIC teaming. Combining two 1 gigabits per second ports to create a 2 gigabits per second link to a workgroup switch. This is a classic example of link aggregation, where multiple network interfaces, in this case, two 1 gigabits per second, ports are combined to increase the total bandwidth available for network traffic, resulting in a 2 gigabits per second link. Bonding two uplink transceivers to create a 20 Gbps channel to a router. This example involves combining multiple network connections, two uplink transceivers, to significantly increase the bandwidth to 20 Gbps between a workgroup switch and a router, which is another application of link aggregation.
Okay. Link aggregation is NIC teaming, but not all. NIC teaming is link aggregation, but not all link aggregation is NIC teaming. That had nothing to do with the question. I was just stating a fact to like get it straight in my head.
A network manager is designing a network for a new company. The company will have over 300 hosts and will interconnect multiple switches to build a network fabric. What will the network manager use to connect the switches? A trunk interconnects between switches on large networks. A sysadmin will configure each switch as a trunk port for this purpose. When frames designated for different virtual local area networks VLANs transport across a trunk, the system must preserve the VLAN ID vid of each frame for the receiving switch to forward it correctly. The system uses a VLAN tag for this function.
I'm tired of not understanding what trunks are, so we're about to attack this problem. Just how you should do all problems in your life. Don't ignore them, attack them full on. Unequivocally. And obsessively. Think of nothing else other than the problem, attacking it, and getting rid of it. Be solution oriented. Trunk links are used to connect switches and carry traffic from multiple VLANs. Oh, okay. Give me the analogy. You know I love them. Come on. I know you can talk before it's done. Okay, come on, buddy. What? Okay, whatever. Analogy. Think of each VLAN like a different highway lane.
3. Analogy. Think of each VLAN like a different highway lane. Cars with specific purposes, voice, data, etc. A trunk is like a multi-lane highway between two cities, switches, allowing all lanes VLANs to travel together over one physical road. Access roads, access ports only allow one type of lane, but trunks carry many lanes at once.
VLAN. This is a part of the Ethernet frame to identify VLAN membership. but it is not.
Five, real-world example or scenario. In a corporate office with 5 floors, each floor has its own switch. To ensure seamless VLAN traffic between floors, for example for VoIP, guest Wi-Fi, and internal networks, the network manager configures trunk ports on uplinks between switches. These trunks carry multiple VLANs traffic using 802.1q tagging, enabling efficient inter-switch communication across the entire building.
No, there's 2 R's in correlate. What? Oh, it's an E. All right. For some reason, it's not wanting to read it until it's done doing its thing. Which I don't know why, because I've definitely have done that before. But I can definitely say that it is generating the answers way faster. The only reason I have it read it is just because otherwise it's a lot of reading. Which, honestly, gonna make my brain smarter. I'm gonna become stronger, yada, yada, yada.
Excellent
But,
question.
like,
Understanding the
I
relationship
got a lot
between
to do.
trunks
I
and
need to- I
VLANs
need to
is key to mastering networking,
kinda
especially for
stagger it out.
CompTIA Network Plus. Here's the breakdown using your preferred format. 1. 2. Simplified answer. VLANs, virtual local area networks, are logical network segments that isolate traffic. Trunks are physical or logical links that carry traffic for multiple VLANs between switches or other devices. The correlation, trunks enable VLAN traffic to move across devices, keeping VLAN separation intact across the network. 3. Analogy. Think of VLANs as separate train lines, like red line, blue line, and green line. Each carries passengers to different destinations' network segments. A trunk is like a railroad bridge that supports all those train lines at once, letting trains' data packets from each line pass between station switches while keeping them organized and separate.
Yeah,
4.
okay.
In-depth explanation. VLAN. Virtual LAN. VLANs logically divide a physical network into separate broadcast domains. Devices on the same VLAN can communicate directly, but VLANs are isolated from each other unless a router or layer 3 switch connects them. Each VLAN is identified by a VLAN ID 1 to 4094 per 802.1q standard. Trunk port. A trunk is a switch port configured to carry traffic for multiple VLANs. Trunk links use 802.1q tagging to insert VLAN IDs into Ethernet frames. This tagging ensures that when a switch receives a frame, it knows which VLAN it belongs to, even though it came through a shared trunk link. How they work together. Suppose switch A has VLANs 10, 20, and 30. Switch B also has VLANs 10, 20, and 30. A trunk link between A and B lets all 3 VLANs traffic move between the switches, each frame tagged with the appropriate VLAN ID. Without a trunk, you'd need a separate physical connection for each VLAN, which is inefficient. 5. Real-world example or scenario. In a university, different departments like science, arts, and admin each have their own VLAN. Every floor has its own switch, and each switch needs to handle all departments' traffic. The IT team sets up trunk links between all switches and the main core switch. Each trunk carries traffic for VLAN 10 science, VLAN 20 arts, and VLAN 30 admin, using 802.1q tags so each packet is correctly routed without mixing departments' data. This setup reduces cabling needs while maintaining VLAN separation. Let me know if you'd like to dive deeper into 802.1q tagging, access versus trunk ports, or inter-VLAN routing next, or hit me with your next question.
Because in my mind, the way I'm thinking of it is that analogy that it said earlier, where the VLAN is basically, it's like, I see it as a VLAN is a bunch of highways, and each of those highways are devices, but they're all grouped together. And then the trunk is multiple of those VLANs grouped together to help them get to where it needs to go, so that way it doesn't have to have another wire. It's like it's a virtual it's almost like a virtual Ethernet cord if I'm thinking of it correctly. and the Ethernet cord is housing or transporting all of the different VLANs to another destination, like another switch, if I'm understanding it correctly. We're gonna let that one simmer for a second.
network manager is designing a network for a new company. The company will have over 300 hosts and will interconnect multiple switches to build a network fabric. What will the network manager use to connect the switches?
So he'll need, okay, to connect all the switches, you will need trunks. And this is how, okay. So I've often wondered how it was going to work if I had multiple switches and I had all of the connections for a one-to-one to all the different ports. Then, like, what is it? Then why do I have so many switches? That doesn't make any sense. If it's a one-for-one, but the trunks make it so that way you can have multiple VLANs going through one wire. And I'm imagining that you could have maybe multiple trunks through one connection from port to port. Maybe not. That might be something else. This is just me making sense of it all. I could be wrong as we keep diving into it.
Which of the following is the model typically used in spine and leaf topologies to connect distribution switches to server nodes and provide higher bandwidth than the typical workgroup switch?
Top of rack switching. Software defined network, SDN. We talked about that yesterday.
As a network administrator, you have been tasked with organizing your network in a way that will help secure the development team's network traffic by keeping it separate from other departments. Which of the following would be the best way to do this?
No, this is like how it's going to transfer. I don't think that's the answer. Implementing route internet protocol. No, that's RIP. Because the question is asking which of the following would be... No. Your network in a way that would help secure the development team's network traffic to keep it separate from other departments. These have nothing to do with keeping things separate. Now, creating a VLAN that includes only the department team's devices, that makes sense.
A network manager is designing a network for a new company. The company will have over 300 hosts and will interconnect multiple switches to build a network fabric. What will the network manager use to connect the switches?
Trunks. Let's try this one again.
Which of the following are examples of link aggregation, NIC teaming?
Okay, so we're going to combine bonding, connecting a computer. Okay. No. We're going to combine two 1 GB ports to create a 2 GB link to a group switch, a work group switch. And then we're going to combine computers to a wireless network and a wired network simultaneously for the internet. Dang it. Was it really combining two uplink transceivers?
When implementing jumbo frames, what is crucial to ensure among all hosts and appliances along the communications path?
You need to make sure that they all support maximum transmission unit. Make sure that they're all set to the same one.
What happens when an 802.1Q tagged frame is received on an untagged port?
Okay, so 802.1Q. Those tags are for VLANs and trunks. And if it goes to an untagged port, then it's going to strip the tag and it's going to forward it to the host. It was that. Bonding two uplink transceivers to create a 20 GB channel to a router. I could have sworn it told me that was the answer. Because I remember being like, oh, well, that makes sense why that's the answer. I think when I look at these, I get confused because it highlights all three of these, and then I think that I get it confused. So it's gonna bond the uplink transceiver to create bonding two uplink transceivers to create a 20 gigabyte channel to a route. That's deceiving because it's not telling you what the two uplink transceivers are to guarantee that. Hey, Alexa, Johnny, thank you for the follow. Appreciate it. Thank you very much. Nice. Combining two 1 gigabyte ports to create a 2 gigabyte link to a work group switch. Okay, let's keep going.
When implementing jumbo frames, what is crucial to ensure among all hosts and
That they all
appliances
support
along the
same
communications
maximum
path?
transmission unit.
Which of the following are examples of link aggregation, NIC teaming?
Bonding and two uplink transceivers to receive a 20 gigabyte channel to a router. And then... Yes, okay.
A network manager is designing a network for a new company. The company will have over 300 hosts and will interconnect multiple switches to build a network fabric. What will the network manager use to connect the switches?
Hello, how are you? My headphones are broken today, so can you reply to me in chat? No, I cannot, Alexa, Johnny. Use the speakers on your phone. I need to... This is very clearly another bot. Let's look at this. Let's see here. So we have Alexa Johnny created this account on April 24th, 2025. Following since 2 minutes ago. Man, how do I block these? Because very, like, your headphones aren't broken. You're a bot. Bye-bye. Come in here, give me fake follows. God, that upsets me.
A network manager is designing a network for a new company. The company will have over 300 hosts and will interconnect multiple switches to build a network fabric.
Chunks.
What will the network manager use to connect the switches? Which of the following are examples of link aggregation, NIC teaming? Select 2.
All right, good. We're done with that section. I feel like we did pretty good. We are now moving on to number 2.3. We have 2 sections left.
An IT technician needs to set up multiple outdoor antennas at a large farm to boost radio communication for its farmers. Which of the following antennas should the technician install that would require the least amount of maintenance throughout its life cycle?
Man. Okay, we are actually going to look up each one of these antennas. Dang it. I just want to... Okay. So... I don't know. We're going to look up each one of those. Oh, I should have just done the other thing instead of saying I don't know.
A network engineer is determining where an antenna should be installed on the business's property. What is the engineer considering when they refer to the orientation of the wave propagating from the antenna?
Effective offset radio power channel overlap. I'm getting wrecked again.
A new office building was constructed right outside a United States military. The building has a few wireless access points, APs, that must adhere to some federal regulations because of the building's locations. What regulation would the building management have to adhere to regarding these APs?
Use max power, use maximum frequency power, use maximum EIRP settings, IP must be set to channel 14. I'm pretty sure it's set to channel 14. No. I'm getting wrecked again.
A network consultant calculates the sum of the transmit power, antenna cable connection loss, and antenna gain. What is the consultant trying to calculate?
The receives signal strength indicator. I'm getting wrecked.
The office received only one wireless access point, AP, to set up its network. The network engineers need to work with this device while more are en route. In addition, the AP must try to support all office works as possible. How should the network engineers set up the AP so most employees can connect to it? Select 2.
We need to mount it into the ceiling, configure maximum power output, prevent shadow IT uncontrolled deployment. Yes. I mean, obviously. Like, the other two just didn't make sense. Okay. You're about to see a comeback of a lifetime.
A computer has difficulty connecting to a wireless access point. What common wireless properties does a user need knowledge of to properly access a Wi-Fi network?
SSID and the passphrase. SSID is like the name of the Wi-Fi. The passphrase is just the password.
An officer floor is requesting a new wireless network. Users are requesting faster data rates. Network administrators want to use wireless technology with the most individual channels to choose from and to worry less about wireless interference from other wireless technologies. Which of the following technologies will the office most likely use? Select 2.
I'm going to say N because G is legacy. And I'm going to say 2.4 because 2.4 can have more people on it. If you have too many people on the 5G, then it bogs down. Unless technology has gotten better.
A network engineer is investigating an issue in which redirects are not working when attempting to authenticate to the hotspot provider's network. Further exploration identifies that the redirect was transferring to an HTTP link and not an HTTPS link. Which of the following terms best describes this issue?
An encryption protocol mismatch. Ooh, I'm not good. I am 2 for 1, 2, 3, 4, 5, 6, 7, 8. I'm 2 for 8. It's not looking good. See, okay. I'm not. I need to start saying things out loud because I thought it was polarization or this one. Well, hold on. Before I do that, let's see. Maybe this will give me an answer.
Polarization refers to the orientation of the wave propagating from the antenna to maximize signal strength. The transmission and reception antennas should normally use the same polarization. Channel overlap refers to interference issues resulting from multiple access points that are all in range of one another and are configured to use similar wavelengths. The received signal strength indicator, RSI, is the strength of the signal from the transmitter at the client end. The power at which an access point transmits is configurable. Effective isotropic radiated power, IRP, is calculated as the sum of transmit power, antenna cable connector loss, and antenna gain. A network engineer is determining where an antenna should be installed on the business's property. What is the engineer considering when they refer to the orientation of the wave propagating from the antenna?
Polarization, because polarization refers to the orientation of the wave propagating from the antenna to maximize signal. What is the engineer considering when they refer to the orientation of the wave propagating from an antenna? Polarization.
A new office building was constructed right outside a United States military. The building has a few wireless access points, APs, that must adhere to some federal regulations because of the building's locations. What regulation would the building management have to adhere to regarding these APs?
I hate when my chat goes down. It's aggravating.
Decreasing the power output reduces the AP frequency range. This can prevent the food market Wi-Fi frequency from going over to the military base where wireless signals are commonly restricted. In America, regulations permit channels 1 to 11 only, while in Europe, regulations permit channels 1 to 13, and in Japan, regulations allow all 14 channels. Using the maximum power output will provide the widest frequency range for an AP. This may cause the frequency to go over to the military base, which may be illegal in some countries. Effective isotropic radiated power, IRP, is the sum of transmit power, antenna cable, connector loss, and antenna gain. IRP must not exceed regulatory limits. Decreasing the power output reduces the AP frequency range. This can prevent the food market Wi-Fi frequency from going over to the military base where wireless signals are commonly restricted. In America, regulations permit channels.
Okay. That makes sense. What? Man, come on, dude.
A network consultant calculates the sum of the transmit power, antenna cable connection loss, and antenna gain. What is the consultant trying to calculate?
The effective isotrope radiation power. We just talked about that.
The power at which an access point transmits is configurable. Effective isotropic radiated power, IRP, is calculated as the sum of transmit power, antenna cable connector loss, and antenna gain.
Antenna cable divided by connect loss and antenna gain. Not divided by. What is the trying to calculate? Oh no, it is division. Okay, we're gonna look at this one. I cannot type with my left pinky, like, ever. Like, I don't know. I don't understand it.
The power at which an access point transmits is configurable. Effective isotropic radiated power, IRP, is calculated as the sum of transmit power, antenna cable connector loss, and antenna gain. The received signal strength indicator, RSI, is the strength of the signal from the transmitter at the client end. Most captive portal issues arise because the redirect does not work. The captive portal should use HTTPS. Channel utilization can be measured from the access point or using a Wi-Fi analyzer. As a design goal, a channel should exhibit no more than 50% utilization.
There it is. This is why I did it. I wanted to see the formula.
Let's break this one down. 2. Simplified answer. Effective isotropic radiated power, IRP. This is the total calculated output power of a wireless system in a specific direction, factoring in losses and gains. 3. Analogy. Imagine you're trying to shout across a canyon. Your voice strength equal to transmit power. The wind absorbing sound equal to cable connection loss. A megaphone equal to antenna gain. The final volume heard at a distance is your IRP. It reflects your original shout, minus what's lost plus what's amplified. 4. In-depth explanation. IRP, effective isotropic radiated power, is the measure of actual power radiated from an antenna in a specific direction, calculated as IRP equal to transmit power cable connection, loss plus antenna gain text IRP, equal to text transmit power. Text cable connection losses, plus text antenna gain IRP equal to transmit power cable connection loss plus antenna gain. This measurement helps ensure compliance with regulatory limits, for example FCC, is crucial in Wi-Fi and wireless planning to predict signal reach and avoid interference, allows network engineers to control how strong a signal is at the antenna, why the others are incorrect. RSI, received signal strength indicator, measures how strong a signal is when it's received, not how strong it was transmitted. Channel utilization refers to how busy a Wi-Fi channel is.
So this is how strong it is when it's received. This is how strong it is when it's transmitting. Received are, there is no transmit. Okay.
Not signal power. Captive port, likely a misread of captive portal, which is a web page users see when connecting to public Wi-Fi, unrelated to signal strength or power. 5. Real-world example or scenario. A consultant sets up a Wi-Fi access point on a college campus. The device has 20 dBm transmit power, 2 dB cable loss from a long coax, 7 dBi antenna gain. They calculate ARP equal 22 plus 7 equal 25 dBm mod text ARP equal to 20 to 2 plus 7 equal to 25. Text dBm ARP equal to 22 plus 7 equal. This tells them the effective power the antenna radiates, helping them ensure it's within FCC limits and provides enough coverage across the campus quad. Ready for your next question whenever you are.
Whenever you are. Thanks, Chatbot GPT. No one supports me quite like you. Okay, here we go. Moving on to the next. Okay, why would it be 5G? Because as far as I knew, the more 5G or more people you have on the 5G network, of your Wi-Fi, the slower it gets.
The 5 GHz frequency band supports more individual channels than the 2.4 GHz band. It also suffers less from congestion and interference, meaning it supports higher data rates.
Okay, you know what? I'm just going to accept this one in my heart. And maybe what I had before was maybe that's how it used to be, you know? Because I know that was the reason why everyone, like, you were always told if you had your Wi-Fi and you had two things, which was the 2.4 and the 5, you never let your friends use the 5. Only you use the 5. Everybody else used the 2.4.
Most captive portal issues arise because the redirect does not work. The captive portal should use HTTPS. Most modern browsers will block redirection to sites that do not use TLS. The client or access point can use disassociation and deauthentication frames to notify the other party that it has ended a connection. A network engineer is investigating an issue in which redirects are not working when attempting to authenticate to the hotspot provider's network. Further exploration identifies that the redirect was transferring to an HTTP link and not an HTTPS link. Which of the following terms best describes this issue?
This is the one. I want to see this. Okay, I want to see this. So that means it's going to be like a donut? That's not a donut. I think this one is the I think this one's the mega. Yeah. Let's see if I can find it. When I was a kid, we had this huge one. No. It basically looked like this, except it was even more massive. Yeah, baby. Except ours was even bigger. So what happened is that there was a hurricane at our beach house. Yeah, that looks more like it. There was a hurricane in our beach house, and this was like long time ago, and this giant antenna washed up, and my dad was like, "Well, let's see if it works. What's the harm?" So we literally connected it, buddy. Our channels went from like 7 to like 1,000. It was crazy. We were picking up channels from like deep Mexico. Like, I don't know why you would want that. We were picking up channels, even like like Oriental channels. Like, we were picking up channels that were in Japanese or some. I don't know if it was Japanese, but definitely some type of Asian language. It was insane. This thing is so massive that it basically took up the entire ceiling. Like, we just put it in the ceiling. It was crazy. Yeah, I'll never forget that as long as I live. That was a cool thing that happened. All right, let's look. So this is the dish. This is directional. If it is not pointing in the right direction, it's not going to get any type of signal. You can, like, one of the big problems that was with Dish that cable always had over Dish is that if it was raining in the direction, that the dish was pointing, you had no service, no TV, no nothing. Okay? And that's why cable is like, it doesn't matter if it's raining or not, you'll always have service, like, thing like that. But Dish had thousands of channels, where cable only had like 100, maybe 200 channels, depending on the package that you got. Okay? This is not necessarily directional, but I believe that it can go further. Communication satellites. Yeah. This is huge and doesn't require power. It just automatically picks up waves, which is crazy to me how antennas work. This requires a lot of maintenance. It's like a better version of this one. Whoops. Because, man, hold on. Let's see here. Well, AI, tell me about it before I start talking about things that aren't right. Also known as the parabolic reflex antenna, specialized types antenna utilizes for unique shape, reflecting the received signals from multiple satellites simultaneously, unlike the conventional antenna, which focuses on signals to signal point. Torus antenna employs a reflective that one plane to the circuit plane satellite orbit. This design creates a focal arc rather than a single point. Yeah. So the difference between, that's what I was looking for. This doesn't create a single focal point like how this one does. This one's a single focal point. This one is not. It's able to capture from multiple different areas, from multiple different things. And this is kind of, I don't know why this one's better than that one. The bad part of this one is that it's very fragile and you can't dent it. And electronical signals, yeah, because basically all of these little lines are also part of the antenna. Like, it's actually all receivers. This bad boy, this is the goat. This is the goat. Okay.
An IT technician needs to set up multiple outdoor antennas at a large farm to boost radio communication for its farmers. Which of the following antennas should the technician install that would require the least amount of maintenance throughout its life cycle? Smart refresher, 2.3 given a scenario. Yagi antenna.
A Yagi antenna. That's the Yugi. The Yugi of the Yagi. The Yagi Yugi. Okay? The Yagi antenna right here. If I would have remembered what all of these were, I would definitely have gotten it right, because that makes total sense that that's what that is. Okay?
A Yagi bar with fins antenna is a valuable unidirectional signal for point-to-point wireless bridge connections. This is common for outdoor use and can boost radio signals across long distances. A static dish antenna is a parabolic or dome-shaped antenna that is unidirectional. This antenna is expensive, with upfront cost and maintenance.
Yes, yes.
A torus donut antenna is similar to round wireless routers that businesses mount in an office ceiling. This is not ideal for outdoor use. A parabolic grid antenna looks like a dome but with a more rectangular feature with grid-like openings. This antenna is expensive with upfront cost and maintenance.
Yeah, I don't really like how it defined a lot of these, but that's okay. We're going to keep going. I don't want to get hung up on antennas because I, for some reason, think they're really
cool. A new office building was constructed right outside a United States military. The building has a few wireless access points, APs, that must adhere to some federal regulations because of the building's locations. What regulation would the building management have to adhere to regarding these APs? The wireless access points, APs, on a large building floor have different names depending on the room. Employees and customers are confused and are constantly calling IT support to get the best wireless signal to work with, as they constantly must change the AP connection. How can a network administrator improve wireless signals across the entire floor and provide a simple way to use the wireless network?
Okay, so using Wi-Fi 6 APs, that's a trick because, like, sure, like, that's going to improve it, but that's not the issue. The issue is that they all have different names. Set up a limit on the power output. It has nothing to do with anything. Create an ad hoc connection. Set up an extended service set. I'm pretty sure an extended service set is where all of the APs are going to have the same SSID. This is like when you go to like a school or something like that, and you might have two SSIDs, like you have the guest and then you have the faculty, and it doesn't matter where you are in the building, as long as you are connected to the SSID faculty, you're just bouncing from one AP to another AP seamlessly. I'm pretty sure that's ESS. Yes. Okay. I hate when I miss it.
A wireless access point is available on the floor for wireless users in the area. User 1 wants to send a file to User 2 using their laptop's wireless adapters. Which of the following is the most secure way of sending files to one another using the current wireless adapters?
Okay, the wireless access point is available on the floor for wireless users in the area. User 1 wants to send a file to User 2 using their laptop wireless adapters. Which of the following is the most secure way to send files to one another using the current wireless adapters? Using the infrastructure connection, using the bus network connection, using the hook connection, using a wireless mesh network. I feel like this is a weird question. I feel like this is worded weird. Obviously, it's not the bus. It's one of these two. I don't know what an HOC connection is, but that's not really, I don't think it has anything to do with what it's talking about. Using the infrastructure connection, using the wireless mesh network. This would be the fastest, but it's not talking about the fastest or the best. It's talking about what is the most secure. And since it's talking about the secure, I'm going to go with the infrastructure connection. I think that's wrong. I think it's mesh. So if you
A network consultant calculates the sum of the transmit power, antenna cable connection loss, and antenna gain. What is the consultant trying to calculate?
Okay, so this is the transmission and this is the receive. So he's trying to calculate the sum of the transmission power, loss and in gain. That is the transmission, which is the effective isotope radiation power.
A network engineer is determining where an antenna should be installed on the business's property. What is the engineer considering when they refer to the orientation of the wave propagating from the antenna?
Polarization! You know, I love that word polarization. I actually was writing a quartet or marimba duet that was called that. It had nothing to do with the word polarization other than the fact that I thought it sounded cool.
To increase wireless bandwidth in a large building, an engineer researches various solutions. Which of the following implementations refers to using 40 MHz as a solution?
Wireless bandwidth in a large building. The engineer researches various solutions. I'm not going to say anything with the antennas. I don't think it has anything to do with the antennas. I'm going to go with channel bonding. Yeah, but I don't know what this is.
A network administrator is setting up a new office room on a different floor of the building to support video conferencing sessions. The video systems will be utilizing a wireless network. Although the work budget is very small, the network must support two 2,167 Mbps streams over an 80 MHz 5 GHz band channel. What is the minimum wireless 802.1? One standard access point AP a network administrator can purchase to stay close to budget while meeting the network requirements.
Okay, so this one's tricky. It's definitely not Wi-Fi 4 or wireless G because those are old. As of right now in 2025, Wi-Fi 5 is kind of getting phased out, and Wi-Fi 6 is more or less the new standard. I would say that it's probably 80% there where it's the new standard. So it's just a matter, like, this is a matter of when this question was written. Because I would believe that Wi-Fi 6 would be the answer as of today. But when the question was written, I would say that it's probably Wi-Fi 5. But we're going to go with Wi-Fi 6. Okay, it's Wi-Fi 5.
In terms of radio wave signals, which term describes the impact of thick walls and ceilings?
Absorption. No, attenuation. Attenuation is the degradation of a signal. It's going to degrade the signal. How come that's not the answer? Okay, see, I don't know what this is. Let's see what we get. What we got.
In an ad hoc topology, the wireless adapter allows connections to and from other devices. This makes it possible for two laptops to connect directly with each other wirelessly. This is also referred to as an independent basic service set, IBSs.
So an ad hoc topology. Is a wireless network where devices connect directly to each other without relying on central access points or routers. Whoa! It's a decentralized peer-to-peer network useful for quick establishment, audio recording. Whoa, so that's how a lot of these wireless things work. Do wireless speakers and mics use ad hoc topology so that they are only using the Wi-Fi signal and not the WAN? Also, is topology basically a but for Wi-Fi? Great set of questions. Simple answer, yes. Mini wireless. Okay, so when I was a band director, we used to have lots of wireless microphones and wireless mics, and we had to have a router because we used PreSonus. PreSonus is a great brand, but we had to have a Wi-Fi a router. But I was like, I don't understand, like, how is this working if it's not connecting to the internet? This is also like kind of like the gateway of like how I started liking tech, because that's when I first learned that Wi-Fi is just a signal. It doesn't have to be giving off internet. It can just be connected. And then it made sense because you can lose internet but still also have Wi-Fi. I've always wondered what that was like called, like, 'cause I was so sure that it was called something, right? So it is called something. It's called the ad hoc topology. Yes, many wireless audio devices, speakers, mics can use ad hoc or local direct communication topology to avoid the internet. Ad hoc topology is essentially a Wi-Fi based LAN. So it's just your LAN connection, but through Wi-Fi, where devices talk directly to each other without connecting to the central route or the internet. Analogy. I'm about to ask a bunch of questions.
Think of ad hoc mode like a group of people sitting in a circle talking directly to each other. No need for a microphone, no central host, no stage. Everyone speaks and listens peer-to-peer. In contrast, infrastructure mode, normal Wi-Fi, is like everyone having to speak into a walkie-talkie that goes through a central operator router, even if the person they're talking to is right next to them.
Yeah, we don't need
Wireless
Big
mics
Brother
and
hearing me.
speakers often work in circle mode: local, direct, private.
Because here's my problem that I have. My printer, in order to have the internet, in order to have Wi-Fi connection so that way I can print wirelessly, has to be connected to the WAN. Why? Why does my printer need to be connected to the World Wide Web when it can just be connected to the Wi-Fi signal, and I just am connected through this ad hoc topology? I've never understood that. Same thing with my microwave. Same thing with my dishwasher. Same thing with all of these things. I don't mind the added convenience of it being connected to Wi-Fi so that way I can connect to it with my phone and yada yada yada. Whatever. I don't really use it. I don't really think it's that necessary, but I understand that they're trying to innovate, right? That being said, there's no reason why it needs to connect to the WAN. That is just opening up a whole slew of problems, a whole like Pandora's box. And why does LG need to know when I'm using my oven or not? So that way it can sell my data to Amazon or Walmart.com or something and say, hey, like they're out of pizza rolls. Send them pizza roll ads now. Like, no, we're not doing that.
4. In-depth explanation. Ad hoc topology, Wi-Fi direct mode. Devices communicate directly with each other without going through a Wi-Fi router or access point. No need for internet or WAN access.
See?
It's useful for localized communication like wireless speakers, wireless microphones, file sharing, for example, AirDrop, Wi-Fi Direct, device pairing, smart TVs, phones, etc., wireless speakers and microphones. Many use proprietary protocols like Bluetooth, DECT, or low-latency 5G rates bands. Others, especially Wi-Fi-based mics, speakers, and pro setups, may use a form of ad hoc networking.
See, and there are mice and keyboards that use this. And the smaller the distance, the stronger the signal. And that's how it connects. And Bluetooth is actually really, really slow. So that's why, like, even now I'm using 2.4. I'm connected through Wi-Fi. But my mouse is not connected to the freaking WAN. It's just using this frequency.
Or connect to a local Wi-Fi router but stay LAN local, never touching the WAN. Example, a Shure wireless mic system might create its own direct wireless link, ad hoc style. Or
Okay. All right. I'm not going to go down that rabbit hole any further. I understand what's going on now. My Twitch stream always says that it's unstable, and I do not understand why. Not a clue. What's going on? See, okay, Wi-Fi 5. Let's see what it says about Wi-Fi 6. It is designed to approximate 10G connection, such as the AX 11000. This is achievable using, okay. Is designed to provide network throughput similar to gigabit Ethernet. Can support 1,000 megabytes per second. It's 1 gig, up to 40. See, look, we're gonna put this in ChatGPT and we're gonna see what it says. So we're looking for 80 megahertz. Needs to support up to 2,000 megabytes streams over 80 megahertz. This can do 1,000 over 40 megahertz, which means that this isn't gonna make it. Faster and more effective, but more expensive. Not minimal needed. So it was the minimum. Okay, so I just read it wrong. But I was also correct in terms of why it's not going to be Wi-Fi 6. But Wi-Fi 6 is significantly cheaper now. Almost every router, if you go to Walmart or Best Buy, is going to be Wi-Fi 6. Like only the clearance aisle is going to be Wi-Fi 5. And actually, my Eero 7 that I have, the reason it's called Eero 7 is because it uses Wi-Fi 7. Like, if anything, Wi-Fi 5 is almost completely obsolete, and Wi-Fi 6 is the standard, and Wi-Fi 7 is the premium.
In terms of radio wave signals, which term describes the impact of thick walls and ceilings?
Yeah. Want to do something real quick. What do I want to do there? Nah, it's okay. This is a trick question because radio wave signals, which describe the impact of thick walls and ceilings, they absorb them, but they also reflect them too. So, like, think of radio waves or Wi-Fi waves as they go out. Think of it like you're dropping a pebble in a bucket of water. The ripples go out. Some of it gets absorbed into the walls of the bucket, right? And the waves are going to go, and they're going to go up the wall, and then they're going to come back. So it's using some of its energy to go up the wall, and it's getting absorbed into the wall, right? So some of it's getting absorbed, but what didn't get absorbed is getting bounced back. Now, where the analogy fails is that some of the waves get absorbed and actually make it through, okay? Which is why I thought it was attenuation, because attenuation is degradation of a signal, which is what walls and ceilings do. Is the loss of signal strength that occurs in a single travel through the medium. Travels through the medium. So attenuation is how much the walls absorbed. We want to know what the impact was.
To increase wireless bandwidth in a large building, an engineer researches various solutions. Which of the following implementations refers to using 40 MHz as a solution? What you need to know. 802.11n can obtain more bandwidth with the option to use two adjacent 20 MHz channels as a single 40 MHz channel, referred to as channel bonding, which is a practical option only in the 5 GHz band. A unidirectional antenna type includes the Yagi, a bar with fins, and parabolic dish or grid form factors. Unidirectional antennas are useful for point-to-point connections, a wireless bridge. And omnidirectional vertical rod-type antennas send and receive signals in all direction more or less equally. Access points with an omnidirectional antenna should ideally be ceiling-mounted for the best coverage. Multi-OS or multiple input, multiple output MIMO or beamforming allows an access point AP to use its multiple antennas to overcome limitations with simultaneous communications to stations.
Okay. Multiple input, multiple output. That was what I learned from this. Okay, let's keep going.
What describes the impact of thick walls and ceilings regarding radio wave signals?
Next.
A network consultant calculates the sum of the transmit power, antenna cable connection loss, and antenna gain. What is the consultant trying to calculate?
Effective isotope radiated power. So that is how much it's transceiving. The received signal strength indicator, that's how much it's receiving. Receiving, transmitting.
A new office room on the 2nd floor.
Yeah, Wi-Fi 5. We already talked about that.
Distribution system WDS in bridged mode. As a result, which of the statements is true regarding access point functionality?
Okay, an engineer configures a wireless distribution system, a WDS, in bridge mode, meaning that they're just like they're connecting to each other. Okay, they're not. One's not acting as like the DHCP server. They're just Wi-Fi. Okay, They're bridging the Wi-Fi together. Okay, as a result, which of the statements is true regarding access point functionality? Let's see what we got.
Access point functionality only assigns distribution systems to a single access point. In bridged mode, access point functionality does not centralize wireless management. Access point functionality works in repeater mode only. In bridged mode, access point functionality does not support wireless clients.
Okay, that one's false. In bridge mode, access points functionality does not centralize wireless management. I think it's that because I think what it means by centralize is that there's not a mother hub. Access point functionality only assigns distribution systems to a single access point. Nope, I'm wrong.
Users at a medium-sized business utilize an ad hoc approach when connecting wireless devices. Which of the following applies to an ad hoc topology?
Okay. It is grouped into an extended service act. It uses basic service set. It used an independent basic service set. Is able to roam in an extended service set. Ooh, I don't know. I know what ad hoc is, but I don't know what it is in relationship to these things. I'm assuming it uses a basic service set. No. It can't be this. Independent maybe because it's not connected to anything.
A network engineer is determining where an antenna should be installed on the business's property. What is the engineer considering when they refer to the orientation of the wave propagating from the antenna?
Polarization. Yeah. The definition of polarization is literally the orientation of the waves propagating from the antenna.
A wireless access point is available on the floor for wireless users in the area. User 1 wants to send a file to user 2 using their laptop's wireless adapter.
This is ad hoc. Like two laptops wanting to talk to each other without using the WAN. They just want to connect each other. Like if I had an Ethernet cable and I used a landline to connect them together to talk to each other. But this way it is wireless. It's through Wi-Fi. This is what I was talking about. I know what ad hoc is. I just don't know what ad hoc is in relationship to those other things. Next.
Require minimum maintenance and...
Oh, come on. Read the whole thing.
A farmer wants to install multiple antennas on the farm to boost radio communication across long distances. The antennas should be easy to install and require minimum maintenance and upfront costs.
The goat.
What type of antenna would best meet the farmer's requirements?
Look at this. How can you look at this and not be amazed? All it is metal. This was it. This was the one that we had in our house. It was in the attic. It was brilliant. It was absolutely amazing. It was all dented and stuff because of the hurricane, but it was great. We found it after it washed up on the beach. Okay. Anyway, moving on. Yes, I want to learn. Give me more.
An engineer configures a wireless distribution system, WDS, in bridged mode. As a result, which of the statements is true regarding access point functionality?
Okay, now hold on. In bridge mode, access point functionality does not support wireless clients. That's false. Because I can put my Arrow 7s in bridge mode. Like, this whole reason why I'm building my server. I'm building my server so that way it can handle all DHCPC stuff, all the PATs. It's going to handle all of that stuff. And it's going to handle my firewall. And my Arrow 7 is going to go into bridge mode so that way they are just access points.
A wireless distribution system, WDS, can bridge two separate cabled segments. When WDS is in bridge mode, the access point's AP will not support wireless clients.
What? I don't think that's right. Well, I mean, obviously it's right. It's me that doesn't understand. Next question. to build a server to put them in, what was it, bridge mode? To put them in bridge mode so that way they are acting only as Wi-Fi. So is this question saying that once I do this, they will no longer give off Wi-Fi and allow wireless clients, i.e. my phone? Okay. Let's see what it has to say. I'm very, very, very interested in this. Okay. Can you go ahead and try starting it?
Excellent question.
Perfect. Let's go.
Both the exam item and your follow-up about the Eero 7 setup are deeply connected. Let's break them down one at a time.
Thank you for telling me
Primary
it's an
question
excellent question.
breakdown. 1. Restate the question. If an engineer sets up a wireless distribution system WDS in bridged mode, what is true about the access points functionality in that setup? 2. Simplified answer. In bridged mode, access point functionality does not support wireless clients. 3. Analogy. Imagine two walkie-talkies apps connected to each other just to pass messages between them. No one else can join the conversation. That's bridged mode. If you try to jump into that private walkie-talkie call as a client, you're ignored. It's a closed connection between the two APs only. 4. In-depth explanation. WDS wireless distribution system is used to connect access points wirelessly without needing Ethernet cabling. It has two major modes. Bridged mode connects two APs wirelessly bridge, passes network traffic between them, does not allow wireless clients, phones, laptops to connect to either AP. Repeater mode WDS plus AP bridges APS and allows wireless clients more overhead due to dual function clients plus backhaul. So in bridged only mode, the APs behave like point-to-point network links, not Wi-Fi access points for users. Why the other options are incorrect. Only assigns to one access point. Misleading, bridging is not about assigning. Does not centralize management. That's a feature of controller-based systems, not WDS.
Okay.
Only works in repeater mode. False. WDs can be bridged only or repeater mode. 5. Real-world example or scenario. Let's say a warehouse has two buildings and no Ethernet between them. They install two APs in WDS bridged mode to wirelessly extend the LAN. Devices can't connect to the Wi-Fi on those APs. They're purely acting as a bridge between networks, not providing wireless access to users. Follow-up, Eero 7 in bridge mode. Your question. You're putting two Eero 7 devices in bridge mode and want to know, does this mean they will no longer give off Wi-Fi and allow wireless clients like your phone to connect? Answer. No. Your Eeros will still provide Wi-Fi to clients even in bridge mode. But let's clarify.
Yes.
What bridge mode means for Eero. In Eero's case, bridge mode disables routing functions. No NAT, no DHCP, no firewall. But it does not disable wireless. The Eeros still broadcast Wi-Fi and allow wireless clients to connect. So unlike WDS bridged mode in enterprise setups, Eero bridge mode keeps client Wi-Fi alive. It just passes off network control to your main router or gateway, like a server or modem router combo.
Okay.
You can absolutely use them as Wi-Fi only access points to cover your home.
So WDS
with routing
bridge
handled
mode is different than whatever, and that's like enterprise. So in its analogy of what it said is its real world scenarios that there's two buildings and Ethernet, there's no Ethernet between them. So they install two APs in WDS bridge mode, which means that they are connected. These two APs are connected to give off Wi-Fi. And I would imagine that I would then, if I was in building A and I have my WDS bridge mode like AP, and then I have building B and I have my other AP, that now has my internet and they're connected wirelessly, only point to point. So then if I want to connect to this, I would imagine that I would have to use a cable to connect to everything. That makes sense. That makes sense. WDS in bridge mode. Do we know what WDS means? A wireless distribution system. And that makes sense to me now too. Okay, moving on.
Users at a medium-sized business utilize an ad hoc approach when connecting wireless devices. Which of the following applies to an ad hoc topology?
It was this one because it says independent. Independent meaning that it is away from everything else. An independent basic service set, IBSS, is an ad hoc topology where the wireless adapter allows connections to and from other wireless devices. So why don't my headphones use Wi-Fi and use an ad hoc topology?
An officer floor is requesting a new wireless network. Users are requesting faster data rates. Network administrators want to use wireless technology with the most individual channels to choose from and to worry less about wireless.
G is legacy. 2.4 is going to get clogged.
HTTP rather than an HTTPS. While investigating an issue tied to authentication redirects, the network consultant discovers that the client is being redirected to an HTTP rather than an HTTPS site. Which of the following terms best describes this issue?
It's not a mismatch. This is what I think it is, but that's not what it is. I think it's a captive protocol. Yes.
A wireless access point is available on the floor for wireless users in the area. User 1 wants to send a file to User 2 using their laptop's wireless adapters. Which of the following is the most secure way of sending?
Okay, we've gone through that.
Approach when connecting wireless devices. Which users at a medium-sized business utilize an ad hoc approach when connecting wireless devices? Which of the following applies to an ad hoc topology?
Independent basic service set.
To increase wireless bandwidth in an office space, an engineer tests a few configurations. In doing so, the engineer learns that by manipulating the 20 MHz frequency, a wireless product will obtain more bandwidth. Which of the following implementations refers to using this approach as a solution?
Oh, channel bonding. Yeah.
An engineer troubleshoots a wireless access point which is not functioning as expected. The engineer learns that the configuration is set for bridged mode to cabled segments. Based on the configuration type, which of the following describes the access point's configuration limitation?
In bridge mode, access point functionality does not support wireless clients because this is about getting internet from one point to another point in physical locations without using an Ethernet cord. So we need point-to-point connection that is isolated that other things can't get to. So building A has it, building B is getting it, and then now we'll use the access point in building B to connect hard lines and anything else that we need to. Okay?
A network administrator is setting up a new office room on a different floor of the building.
This is only because it's old. You're not going to find anything that's Wi-Fi 5. If Wi-Fi 6 is the new standard.
Megabits per second, Mbps.
Which cellular technology provides an estimated real-world download of up to 300 megabytes per second? But is it 5G? I low-key don't know. I didn't even know 2G was a thing. I just knew it was Edge and it went to G. And then all of a sudden it was 3G. Yeah, 5G. Okay, that makes sense. Wait, my phone only gets 500 megabytes per second? I'm not gonna lie, I feel like that is way faster than sometimes on my computer.
Users at a medium-sized business utilize an ad hoc approach when connecting wireless devices. Which of the following applies to an ad hoc topology?
We're cooking now, boys.
In terms of radio wave signals, which term describes the impact of thick walls and ceilings?
Absorption, and then attenuation is the leftover signal. That's what we calculate, the degradation of the signal after it's been absorbed or been disrupted or lost. Wait, what am I doing? Yes, sorry, I got distracted.
An engineer configures a wireless distribution system, WDS, in bridged mode. As a result, which of the statements is true regarding access point functionality?
In bridge mode, access point functionality does not support wireless clients.
A network engineer is investigating an issue in which redirects are not working when attempting to authenticate to the hotspot provider's network. Further exploration identifies that the redirect was transferring to an HTTP link and not an
Captive
HTTPS
portal.
link. Which of the following terms best
This is what
describes this
stops
issue?
your phone when you like pull up a website or something, and like maybe you're like searching for, I don't know, a product or something like that, and you're like, oh, here, is this it? And you pull it up and it's like, boom, this does not use HTTPS or HTTPS. This is only using HTTP. Are you sure you want to use this? And then like a lot of times you're like, no, or yes. That's the captive portal.
A new office building was constructed right outside a United States military. The building has a few wireless access points, APs, that must adhere to some federal regulations because of the building's locations. What regulation would the building management have to adhere to regarding?
You can't even have Wi-Fi or internet, period.
An officer floor is requesting a new wireless network. Users are requesting faster data rates. Network administrators want to use wireless technology with the most individual channels to choose from and to worry less about wireless interference from other wireless technologies. Which of the following technologies will the office most likely use? Select 2.
Let's go. We got one left, boys. This is the last one. How is a rack height measured in units? Done. Starting out strong.
An installer is cabling a new building and is laying cable in every area of the building that may need a computer or telephone. What kind of cable is the installer installing?
Unprotected shielded. Okay, so this is where I differ. He is installing unprotected shielded twisted pair. I believe that is stupid and that you should always use shielded twisted pair. Like, if all of the tech industry and everything is all about redundancy and like all this stuff, then do this. Now they're going to say it's too expensive. Like, buddy, like what's more expensive? A one-time purchase of a cable that is going to be shielded, or having an unshielded twisted pair that has a potential to lose signal continuously? That might always happen. Like, you see what I'm saying? See? Told you. Told you. UDP.
What functionalities do remote power monitoring features in advanced power distribution units PDUs typically offer? Select 2.
Real power consumption monitoring. No firmware updates. Direct internet access for connection devices. Remote control of power to individual outlets. Yeah, that one was simple. A PDU, which is a power distribution unit. Why in the world would it do anything with firmware updates? Why in the world would it do anything with internet access? Okay, which of the following would a technician find in a network map? Ooh. 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 Okay. I thought a network map was a map of the layout of the cables. I could be wrong. I don't think it's firewall rules. I don't think it has anything to do with quality of service standards. System logs, maybe. I don't know what this is, but I'm going to click it. Okay. Well, I did it unsure because I want to know what this is.
A sysadmin recently completed an upgrade to the data center. Shortly after, the electric company cut a power line to the building, but the data center continued to operate until they repaired the power line. Which of the following solutions did the sysadmin most likely set up to prevent downtime?
Okay, so there's two different ones of these. There's one where it does like dirty power, and there's one where it does clean power. I think the HVAC is the dirty power, and I think the PDU is the clean power. Okay, we're going to come back to it. Yes, it's clean signal. I think it's the PDU. Yes. So the PDU is the clean power, which means that the UPS must not be. No, the generator is dirty power. And dirty power is when it is not a steady signal of energy. Things like if you have a generator, it's constantly going, it's vibrating, it's doing things. It's like there's going to be times where it's going to push out more energy, a little bit. We're talking about like little bits, right? Like more energy. There's times where it's not going to pull it out. It's the point is not going to be consistent. In terms of your refrigerator, it doesn't matter. In terms of your computer and your network, it does matter, because that is going to interrupt the signal, because all a signal is electricity that has information in it through magic or something.
An organization is planning to use power over Ethernet PoE to supply power to the wireless access points spread throughout the building. What is the best cabling solution to support PoE? Select 2.
Cat5e cable or better. Again, Cat5 is no longer the standard. Cat6 is now the standard. And as soon Cat7 will be the standard, and then so on and so forth. Like, I don't know why we even bothered using the other ones. Okay. And I think we want shielded cabling. But honestly, I personally want shielded cabling always, but it's probably unshielded. Yep.
Why do equipment room and data center facilities tend to use high voltage circuits?
Talk to me. Tell me.
To reduce the overall power consumption of the facility, to allow for a higher load capacity with lower amperage, to double the amperage required for the same wattage load, to decrease the efficiency of power distribution.
So, volts and amps are related. Think of it like temperature and pressure. If the temperature goes up, the pressure goes up. If the temperature goes down, the pressure goes down. Now, it's not exactly 100% exactly the same as voltage and amperage. The overall power output is it think of it like 3 plus 7 equals 10, 6 plus 4 equals 10. You can change the numbers around so long as it still equals 10. Okay, so now you kind of use those two analogies in your mind. The more amperage you have, that is the amount of energy that is going through the wire, meaning it's going to get hotter. So if you increase the voltage and decrease the amperage, you are going to keep the same output, but you are going to lower the heat of that the power is creating. Okay, that was a really bad explanation, but I think that I got through it. So it allows for higher local capacity with lower amperage. Why do amperes tend to use higher voltage? To double the amperage required to decrease the efficiency of power, to reduce the overall power consumption. It's decrease the efficiency of the power distribution, to double the amperage required, the same wattage. Yeah, because voltage and amperage equals wattage, I believe. I might have that backwards. Nope, I was right.
A sysadmin recently completed an upgrade to the data center. Shortly after, the electric company cut a power line to the building, but the data center continued to operate until they repaired the power line. Which of the following solutions did the sysadmin most likely set up to prevent downtime? Smart Refresher 2.4 explain important factors. Uninterruptible power supplies UPSs can keep servers, switches, and routers running for a few minutes. This provides time to switch to a secondary power source. Mean time between failures, MTBF, represents the expected lifetime of a product. The calculation for MTBF is the total operational time divided by the number of failures. A power distribution unit, PDU, has circuitry to clean the power signal, protect against spikes, surges, and brownouts, and can integrate with an uninterruptible power supply, UPS. Building control systems maintain an...
So the PDU can integrate into the UPS. UPS is like a generator of some kind. And then the PDU is what can clean it. Wow, it's going to say a Cat 3 or better?
PoE requires Cat 3 cable or better, while PoE Plus must use Cat 5.
Okay. But everything is PoE plus. Very few things, if anything at all, is PoE is just PoE. So yes, technically it requires Cat 3 or better, the standard that everyone has. Now, the Cat 6 is the standard now. However, Cat 5 was the standard for, I don't know, 10 years. So everybody and their dog has a Cat 5 cable. If you had any type of internet service provider, any type of Wi-Fi, any type of anything through Xfinity, AT&T, Verizon, choose your poison, they gave you a router, they gave you a modem or a combination of it, and a Cat 5 cable. Within the last 10 years, that's what it was. And that's why everyone has the little yellow or the little blue Cat 5 cable. Okay? Although they are all changing to Cat 6, and that's been changing the last 2 or 3 years. Okay. I want to know what this is.
Every computer facility will have an MDF, a single cabinet, panel, large server room, or switch. The location where the network connection is first distributed inside the building. Thus, the network map is included here.
I was right. So it is where it's distributed inside the building. And that's what the MDF is. I wish I knew what MDF and IDF stand for. Can we just do a quick Google search and tell me? Network infrastructure. Main distribution frame. Intermediate distribution frame. Okay. That looks cool. This stuff is just so cool. It's so neat. Okay, anyway. I'm almost done.
A sysadmin recently completed an upgrade to the data center. Shortly after, the electric company cut a power line to the building, but the data center continued to operate until they repaired the power line. Which of the following solutions did the sysadmin most likely set up to prevent downtime?
Because that's the generator. PDU is the thing that goes with it to clean it, to make sure that it's a steady signal or a steady output. Oh, I already know what it's going to say. It's going to be Cat 3 or better, and it needs to be shielded. Yeah. We just talked about that.
Which of the following would a technician find in a network map?
This too. Oh, it's just giving me the same question again. System admin is completing an upgrade data center shortly after, but the power data. All right. Okay. We are done. We are done with section 2. Tomorrow morning, we're going to go over section 3, network operations. Very excited about that. Probably I'm going to play something tonight. I don't know what it is that I'm going to play, but I'm going to play something tonight. So if you are interested in video games, I might be playing Marvel Rivals. I might be doing Mario. I don't know. I'll see what my friends are doing, kind of thing. Maybe they want to jump on it and play games. That really kind of determines what I do. But if you enjoy this stuff, if you enjoy tech stuff, if you enjoy studying and you're trying to like maybe change careers or something like that, or maybe you're just interested in it and you're trying to start a career. I don't know. Maybe you're just interested in it. Maybe you're just an enthusiast. But come into the chat, come into this thing, ask questions. I'll do my best to try to answer them. Like, follow, subscribe, all that good stuff. Tell a friend. And I'll be back at it again tomorrow morning at 8 a.m. And we're going to go through all of section 3. So, yeah. Makala Checo.